Welcome online, everybody, and welcome to Finnish Satellite Workshop 2021. I hope you can hear me. I'm your host, Jan Brax, for today and tomorrow. And as you see, this year, Finnish Satellite Workshop is going to be entirely online event. So let's check first, do we have sound and everything all right? Can somebody speak up and say hello and tell how does the sound and picture reaches you?
Hello, you are
Hello,
loud and
everybody.
clear.
Hello.
Can hear you.
So
Mhm.
let's
I have a bit of
slowly start. And today the first item in the program, let's take a very quick view to the program, what kind of program we have today. And first, we will start with a plenary session. I'm very glad to welcome all the plenary speakers. And after that, we're going to have several scientific sessions in breakout rooms. Then we have an industry hour, then again a plenary session. And then we have also a couple of online talks here, which are interesting for a bigger audience. For example, at slightly after 3 o'clock, we're going to talk with Maija Lönnqvist about Astronaut of Finland. But first, let's take a very short break and see how this all began. We are at the moment having already a fourth Finnish Satellite Workshop. And the first Finnish Satellite Workshop was introduced 2018 by Center of Excellence of Sustainable Space and Aalto University. So Aalto University small satellite team has been behind this conference. 2018 we started with less than 10 companies and around a couple of hundred visitors in Dipoli. 2019 we were reaching already 300 people, and 2020 last year in January we had already approximately 500 people registered. We have had a great time in Dipoli in the framework of this conference. The profile of the conference has been meetings, get together, all about the community, space community. And one of the particular feature of this event is that we are embracing also companies, because you cannot do space or even remote sensing without active participation of companies. So this year, of course, because of the COVID situation, we are trying to do this event as nice and as safe for you as possible online. And let's try to have a good time online as well. So first of all, I would like to thank also our program committee, which is mostly consisting of Finnish Satellite or Center of Excellence of Sustainable Space Steering Group, and also Finnish Society of Remote Sensing Steering Group. So we have this event together with Finnish Remote Sensing Days for the second year already. Approximately half of the program is coming from remote sensing community, and half of the program is coming from small satellite and space technology community. And this year we have had in the history of this event already a very historic record breaking. So we are approaching 800 people registered to the conference, Approximately 2/3 of the participants are coming from Finland, but as you see on the map, we have people all around the world, and probably the online format helps us to reach also the world with our presentations and space technology. So we are keeping to develop this conference to a more international format, and also keeping our partners, our companies on board. So a special thanks to all the partners which are making this conference possible. So the conference works in a way that only companies are paying for the conference. This makes this conference free for everybody else. And you can meet all these different companies during the industry hour. And during the industry hour, you have a possibility to talk with all these companies face to face, ask questions, and go through perhaps a future business plans and so on. Let's also talk a couple of words about how this conference online is arranged. So this is again today's program, and on this main track we are having plenary sessions and discussions, online discussions, and this main track is also streamed to internet, although the stream is visible only at the conference homepage, nowhere else. So the link has been not distributed. Only way to participate the conference is register to the conference, get the registration mail, and link to the Zoom meeting. So the conference technically is just a huge Zoom meeting where we have hundreds of people. And in order to make some kind of order in this, we have all the science sessions in breakout rooms. We have a very short presentation format, only 15 minutes per person. And that means like you should be able to get through your slides approximately in 10 minutes. Otherwise, you are starting to steal the time from other presenters. All the breakout rooms will be opened and closed almost automatically. That means if the session time is over, then the session time is over and the last presentation might be cut. So the sessions are extended 5 minutes from the both sides, so there should be a small transition time available. So as I said, the meeting link, Zoom link, is only link for everybody. Everybody in this Zoom meeting are presenters and partners and participants. They can speak up, they can use their camera, they can share their slides, but we are not assigning anybody to any room. So in order to join a session, please join a breakout room. There is this Windows logo resembling icon somewhere, or then you have these 3 dots in your toolbar of your Zoom. If you click these 3 dots, you will find also breakout rooms, and you will find different sessions by their name. So the breakout rooms are designated with session names. Additionally, we have breakout rooms which are for testing. So people can join freely different breakout rooms, check out their slides and sound and see that everything works, and then come to their science session and present their slides. All the sessions are open for joining and leaving, so anybody can participate in any session or listen to any different presentations. We are also trying to record all the sessions and make some of the sessions also available later on if it's technically possible and if people allow this. So presenters, join your sessions by yourself. There is nobody technically arranging you to the right session. You have to find your session and you have to join your breakout room session in order to give your presentation. And to save time, let's keep also the chairing of the sessions quite short or skip it altogether. People can share the slides and see where they are in the program. Yeah, and for discussions and questions, let's try to use, let's raise hands, and also let's try to use the chat. So you can use the chat in a way also that you can designate your message to certain people only, so you can find the presenter, you take a note who is presenting the interesting presentation, and you can chat with this person online. If you want to present your work, please use share screen opportunity in your Zoom. You don't need to upload anything, you just share your screen and your presentation will appear on everybody's screen. We were already covering how to ask questions, use chat and raise your hand. And if you have any kind of problem with our speaker and microphone or screen sharing, let's try to solve those in the testing rooms. And just a tip or hint to you that when your microphone perhaps or camera is not working, there is a little arrow just beside the microphone and camera button where you can select the device which is broadcasted by Zoom. So often, or most often, the problem is that you have been not choosing the right camera or right microphone from this small arrow, as your computer might have several microphones connected. One might be associated with your earbuds, another one with a laptop, and so on and so on. So let's try to choose the right one from here, and then you can join and be audible. So thank you very much for all this attention on the technical side at the moment. So next, let's start to go forward with our plenary session. And the first presentation is coming from Matti Möttus. Matti, are you online?
Hello, I hope so. Do you hear me?
Excellent. Matti, we are hearing you very, very well. Everything seems to be all right. So Matti is next in the presenting queue. And Matti is going to tell about Forest Digital Twin Earth Precursor. And all this digitalization is a trend of the day and really important trend to follow. And that's why Matti is giving the first presentation. After that, we have greetings from Meteosat, and Jochen Grandel will tell us about Meteosat third generation satellites. And after that, we have a keynote talk about Pegasus program by Ari-Matti Harri from Finnish Meteorological Institute. And at 10 o'clock, we are going to have greetings from Finnish Space Administration. Maija Lönnqvist from Ministry is going to tell what is Finnish Space Administration, how it is organized, and how should we communicate with this administration. And after that, we have a short break and going to the breakout rooms to have the sessions. So as you see, the program is filling the whole day. All right, but next I would give the floor already to Matti Möttus. And Matti, the screen is yours and the floor is yours. Be my guest.
So I hope you see my screen now, and good morning. My name is Matti Möttus and I work at VTT Technical Research Center of Finland at normal times in the Espoo campus, Otaniemi. It is my honor to give the first presentation of the Finnish satellite workshop and remote sensing days. I am giving this presentation on behalf of a consortium which is implementing the Forest Digital Twin Earth Precursor, a project funded by the European Space Agency. The consortium includes my host institute, VTT, University of Helsinki, and companies bringing together expertise in forest system simulation, information management, and forestry. Simosol, which is being merged into AFRY, UNIQ, Cloudfero, and ENCDS, the Romanian Forest Research Institute. My original submission to this workshop included a presentation of the project, first results and outlooks, but as the presentation was promoted to a plenary session, I have now tried to adapt and included topics of interest to a more general audience. So, what's it all about? It's actually something that you have heard of because it's everywhere and it's impossible to avoid. The primary policy ambition of Europe is condensed into the European Green Deal, a set of policy initiatives by the Commission with the aim of making Europe climate neutral by 2050 and decoupling economic growth and from resource use. And more importantly, probably to this community, as a part of the Green Deal, Destination Earth, which is abbreviated with Destiny, capital E in the end, is a major initiative of the Commission, aiming to develop a very high precision digital model of the Earth, a so-called digital twin, to monitor and predict environmental change and human impact to support sustainable development. It's supposed to be evidence-based, so you see also on their logo lots of satellites circling the Earth and making the measurements. With the digital twins, Destiny will help policymakers to monitor and simulate the Earth system developments in different spheres: land, marine, atmosphere, biosphere, and human interventions, and anticipate environmental disasters and the resultant socioeconomic crisis to save lives and avoid large economic downturns, and also enable the development and testing of scenarios for ever more sustainable development. It is foreseen, or there are currently 3 entities implementing the platform and the first 2 digital twins. The European Space Agency, that is commissioning our twin, which is not part of the 2 initial ones listed on this slide. European Centre for Mid-Range Weather Forecasts and European Organization for the Exploitation of Meteorological Satellites, or EUMETSAT. The implementation of the first 2 digital twins has already been started by this European Centre of Mid-Range Weather Forecasts, and these are the digital twin on extreme natural disasters, which will allow to anticipate the occurrence and impacts of extreme natural events, for example, flooding, droughts, forest fires, and the climate change adaptation digital twin, which will be used to predict the impact of climate change at the regional and national levels. Importantly, more twins will follow. Beyond 2023, Destiny will support additional digital twins to achieve a full digital twin of the Earth, or at least that's what is said in the policy document. And now I will get closer to what I am really working on and what this presentation originally was about. This is Forest Digital, on this screen, Forest Digital Twin Earth. Okay, maybe I should get, sorry, Forest Digital Twin Earth. Related to these developments, European Space Agency issued just over a year ago an invitation to tender for digital twin Earth precursors. These precursors will eventually work together with the first two twins, the one on extreme natural disasters and on climate change adaptation, connecting via a common data lake here in this image. The twins will run on a cloud architecture with flexible user interfaces and visualization systems. The consortium led by VTT won the bid for a precursor system describing the forests. The implementation started in last October. And the layout you see here is my understanding of it, and a result of several iterations and lots of improvisation during the progress meetings. The connections that you see here have been created as the project is being implemented. So it has not been an easy game, although an exciting one. So this is what will be the general layout of the Forest Digital Twin Earth and what its precursor tries to look like. We have an ever-increasing volume of Earth observation data, and Open Data Initiative make the national forest databases publicly available. Then we have precise measurements on the functioning of our forests and the climate system, for example, flux towers and weather data resimulation systems. And finally, we have users eager to make a good use of this data. Forest Digital Twin will bring user to the data and data to the user. The user will select an area of interest, and the necessary data will be fetched and pre-processed to the spatial distribution of the forest in the region. So these are Sentinel-2 image resolution in our case. This will be used to initialize a forest ecosystem model, which takes into account the weather data available for the region, including human interventions, to quantify the future of the forests in the area of interest. The updated forests are then given again to the mercy of ecosystem models, which determine their growth under measured or modeled scenarios. The cycle can be repeated, for example, at yearly cycles, which seems reasonable for a forest simulation system. The carbon balance of the ecosystem will be computed, as well as its albedo and the contribution of wood products to carbon sequestration. Finally, the data transformed into information and given to the user in a visualization system, which may be part of the bigger digital twin system. The Earth observation data in Forest Digital Twin comes from high-resolution optical multispectral satellites. On top of that, weather and climate data are needed, and the models used in Forest Digital Twin encapsulate how forests interact with the atmosphere and hydrosphere, grow and store their carbon, and finally decay to provide nutrients for new seasons and generations of trees. As an output, we have dynamic maps of key forest parameters, both forestry parameters and ecosystem parameters, and they are dynamic in a way that they describe change with time. The goal of Forest Digital Twin Precursor is to understand the functioning of forests at very high spatial scales with the potential to cover large areas. Scalability is one of the key requirements for a digital twin. Generally, we foresee that the simulation is done at a yearly time step, but simulation of monthly fluxes to characterize seasonal changes is a necessity for comparing with other similar systems. The system is open source and modular. Depending on the needs of the users, institutional, scientific, or commercial users, other computations may be plugged into the framework. In the precursor stage, the Forest Digital Twin will be tested with users from Finland, Germany, and Romania. The first model runs will be finished by the end of the month. It will be mainly based on optical multispectral satellite data, combined with field measurements on forest structure and also weather information. The system is being implemented on a cloud platform. It is close to being ready at a precursor level, but there have been delays, unfortunately. The data and software are available on the Forest Thematic Exploitation platform, developed also under the lead of VTT. The data infrastructure is that of CreoDIAS, where DIAS here refers to Copernicus Data and Information Access Services. This is a cloud data storage and computing environment. The software comprising the Forest Digital Twin is executed via an API, The outputs are available on the thematic exploitation platform. We try to obtain maximum synergy between the digital twin and other existing products. The project is limited in time and volume and mostly including implementing and porting existing work. The key projects related to this activity are forestry, thematic exploitation platform already mentioned here, but also forest flux and forest carbon monitoring projects, which will be presented later in this workshop. The Forest Digital Twin Earth Precursor has been made available by the strong expertise of consortium members. So the forest models developed by University of Helsinki and Finnish Meteorological Institute, forest simulation software SIMO, which is operated by SIMOSOL, forest thematic exploitation platform, and an extensive network of partners and end users, companies, governmental agencies, scientific and institutional users. So thank you for your attention. Let me see if there is time for questions. I am willing to take them if the chair allows it.
Thank you very much, Matti. Do we have one question online? Then I really encourage you, everybody, to use your messaging system and write a private message directly to Matti and ask the questions from there. So perhaps, Matti, I'm having a very short question myself. How do you think this your approach will scale? So if we are talking about digital twin of entire Earth, it's a rather a lot of bytes and petabytes.
That is the exact question we have to answer to the European Space Agency, and we have answered that yes, we see that it does scale to that level. The key issue are the models which have been tested also for all forest types globally, but still, of course, if you have the same model, the calibration is the issue, as is, for example, the necessity for field data at the current stage. We try to overcome, of course, both shortcomings, but yes, it should embrace the whole Earth, at least theoretically.
All right. So thank you very much, Matti. We will now move forward. The next presentation is coming from Meteosat and EUMETSAT. So Jochen, are you already online?
Hi Jan, I'm here. I hope you can hear me.
Excellent, thank you very much. So let's start technically streaming already the next presentation, and perhaps just out of curiosity, Jochen, welcome online, and can you tell where from you are presenting this presentation this time?
I'm actually from the sauna cabin in Finland.
All right, you are in Finland.
No, I'm on holidays currently. So I used the opportunity of coming here. Yes.
Excellent, and we would like to have, of course, face-to-face meeting, but and have all these members of Finnish space community here in Otaniemi, in Dipoli, having sauna evening also afterwards later on. But at the moment, as we see from the numbers of COVID, it's much safer to enjoy this community online. And I hope and I know that we can do all this important science dissemination also through online tools. Let's learn them and let's work with them. So the next presentation is given by Jochen Grandel from EUMETSAT, and he's going to talk about the third generation of Meteosat satellites. So Jochen, the floor is yours.
Okay, thank you, Jan. I can just say, Jan, it's very nice to see you again after so many years, and also all the other people here in the room, which I cannot see, but I know they are there. I left Finland 20 years ago, and I might have never left if there had been such a vivid space industry as there is today. So I'm really curious to see how, I mean, tremendously this has grown, this industry in Finland in the past 20 years. But anyway, let's go because we have limited time. I will go straight to the presentation. So I work for EUMETSAT, which is an intergovernmental organization in Europe dealing with weather satellites. I mean, many of you have heard of it, but it's usually a little bit, let's say, less known than ESA, for example, even if we share the same roots and we do very strong collaboration with ESA on our satellites. This obviously, like any presentation, is a collaboration of people. I put the kind of the main contributors here, but let's go forward. I hope oh, no, it went too much. Okay, good. So we have actually 2 new satellite programs coming up at EUMETSAT in the next coming years, next few years only. So we have the geostationary program, the Meteosat third generation, MTG, starting in 23, and then we have also the polar system starting in 24. These are both very new developments and very much new capabilities as well involved there. So this is, let's say, a massive change for our users and for us as an organization. So this is really quite a significant step forward. In this talk, I will only concentrate on this blue part. I mean, the geostationary one, because that's where I work as the program scientist. So, okay, so it's a twin satellite concept with 2 different types of satellites, one for imaging and one for sounding. So this is the imaging one now, which is actually the first we will launch in this series. So it is it is continuing the service we have currently. So the kind of a main principle is that whenever we have something new, we have to still continue with the original, let's say, a service as well. So we will continue with the imaging service we have currently on the Severi, the images that second generation, but of course we will improve on that. So we will have a much more capable instrument for that. But then on top of that, we also have a lightning imager, which is a very new development, which hasn't been done in Europe so far. There is an American version of the lightning mapper or lightning imaging already flying since a few years, and there's also a Chinese one. So it's not the first time in geostationary orbit, but it is first time in Europe, or let's say covering European area. The improvements on the imaging side is that we have more channels providing more capability, and then we have also more spatial and temporal, higher spatial and temporal resolution available as well. The start of operations is in 23. We will launch end of next year. I mean, it might slip into January 23, but it's actually a very hard limit because of let's say because of launching capabilities we have available in that time frame. Operational exploitation is roughly 20 years. Okay, and the sounding satellite is otherwise, I mean, the bus is similar, but we have a very different instrumentation there. So it is the sounding missions we have looking into the atmosphere, not just on top of the atmosphere. So we have then the hyperspectral infrared sounding mission, which is the main instrument on that platform. And then we have also a passenger from Copernicus, Sentinel-4, providing atmospheric chemistry services. And then for this, I mean, this will really provide the kind of what we call the 3D weather cube kind of capability. So providing temperature water vapor profiles, for example, every 30 minutes over Europe. It does provide a full disk coverage, not just Europe, but in a less than 30 minutes, let's say higher what am I saying? So it does give 30 minutes over Europe, but it is not so frequent over the rest of the disk. Start of operations is roughly 1 year later than the imaging satellite, because we simply cannot accommodate a launch of such a big system and making it operational of 2 satellites at the same time. So we have to sequence these in a way that we have 1 year in separation. The kind of a new thing on this is that earlier we could more or less only concentrate on the middle part of this of the cycle of a convective storm or convective, let's say, event. So we could only look at the clouds more or less, how they were developing when they were already there, visible, and we couldn't really see very much into the cloud or let's say what was going on there. But now we have this kind of a coin, this kind of a sentence of monitoring convective systems from cradle to grave. So we will be able to monitor also, let's say, the very early stages of convective events or convective storms, from the humidity conversions to convective instabilities, then the development of the convective clouds themselves, which is the part where the imaging part comes in and was already available earlier. And then we will also have the lightning imagery capability, looking at the already mature storm, where we'll have then the lightning events taking place, which is actually going to be very interesting for the exact, let's say, pinpointing of the strongest or most significantly or most severe storm cells within the convective system. I'm not going into details of the technology of any of the missions, because I know we are time limited, and if you're interested, you can contact me and we can discuss further on the, let's say, more details. I'm just highlighting a few things here, which is coming from the new instruments, like the lightning imager, which is not known that much to the main user community who have used only imaging capabilities so far. It does have heritage, of course, from the low Earth orbit as a kind of a science missions, and now we are then going into the geostationary with this one. It does measure the total lightning, what we call total lightning, which is then the cloud to ground and the cloud to cloud combined. We cannot separate those two, but we can see the combined one. The ground-based systems, which are very developed in Europe in many countries, are unfortunately mainly sensitive to the cloud to ground lightning. I mean, they do observe also the cloud to cloud, but with a less significant detection efficiency. But this is, of course, also improving. But I mean, this is still, there are some technical limitations they have with the ground-based systems. Unfortunately, for the let's say operational weather forecaster, the cloud to ground is not always suitable, because it doesn't really work very well for to observe the weather intensification. It says my internet connection is unstable, which is unfortunate. I hope you can still hear me. So we actually want to see the total lightning and not just the cloud to ground part, and this is what we can do with the lightning imager. And also then the important thing is that we can also do observe lightning systems, or let's say convective systems, coming from different parts of your own observation area. In the European case, very often from the west. So European countries are, as you know, divided by their by many things, and one of them is actually their ground-based systems, which are usually national systems, and they don't, let's say, very well share between them, maybe, and then so they don't. Not all countries have access to all other countries' lightning system data. So in this way, you can see a very kind of a full disk image of your lightnings coming to your area. Obviously, in areas like Africa, there is very little lightning data available currently for the weather forecasters. So there, of course, this will be a very significant step forward. The infrared sounder is a completely different beast. It has a very long heritage on the low Earth orbit, with the ASI instrument, which is also mentioned here. I'm not going into details of this one, because this will be a full presentation of its own. I'm just kind of flashing this here. And I have to say, for the Nordic countries, maybe less interesting, because we are very far in the kind of a upper, let's say, slanted path area. So we are looking at profiles, or we are trying to get profiles of the atmosphere with the IRS. And so we would be optimally, of course, looking down. And in the case of Finland, we are approaching already kind of a limb sounding, which is not a bad thing in itself, but it is not what it's designed for. So we can do some work on it, but I think it will be mainly maybe serving the users a little bit further south. Of the imagery, I only have a couple of examples of let's say the improvements we will have. So you have this is not in the same projection as you can see, but the other one is on the left. We have what we currently have available from the Siviri, and on the right we will have what we will then have on the future on the MTG, on the flexible combined imager. So this is on the right is made with MODIS, which is low Earth orbit instrument, and the capability is just kind of demonstrated here. We will also have true color capability because of adding a few new channels. This is another kind of just a very conceptual kind of an example of the improvement. We have the currently available performance with a microphysics RGB, looking at fog detection over the Western Balkans, and this is then the future version of it. I don't know if you can actually see this kind of a sequence the same way I'm showing it. I dropped all my animations because I was almost certain they would not be able to transmit over this link, but maybe you can have some idea anyway of what's going on. And as I said, I have plenty of material otherwise if you're interested in afterwards to discuss with me. Okay, then I promised to have a few words on the geostationary aspect, because I understand that geostationary is not usually the thing that we are looking at in let's say Nordic countries or in Finland, because they're not completely optimally located for geostationary observation, as you can understand. I mean, we are rather north in Finland, which most people realize, but if you talk to people somewhere else, they might not actually realize that. Even in Finland, people don't always realize how far north they are. But this here you can see that we are really in the slanted path. We're almost looking at the limb actually here. So what it means that it is a very simple example of taking one typical Siviri image of the full disk, and this is how Scandinavia or North Europe looks like. So Finland, I mean, north of Finland is already kind of disappearing in the unprocessed area here. So we're not processing all the way to what we can see, because it simply wouldn't be useful, because the models don't work anymore there. This is an example of what happens to the pixel area when you go further north. So this is an example of the lightning imager I just mentioned. Here we have a 4.5 kilometer sub-satellite point resolution. That translates, I mean, the red lines here are like roughly the Finnish latitude limits. So you can see that we roughly go in rather significant pixel sizes here. Of course, for Finland and let's say the further north you go for the lightning imager, this is less and less meaningful, because lightning imaging is not really intended for let's say Nordic countries in that sense. We don't really have that many storms in Finland or areas which would be significant from let's say a meteorological point of view. I mean, of course, when we have lightning, we think it's very significant, but it's very minor compared to some parts of the world. So I think for areas in Finland, I mean, the users in the meteorological community are not going to be too much disturbed by the lack of lightning imaging data, or let's say reduced let's say performance there. We have another one which is the parallax correction. So we have the clouds appear to be in a different place where they actually are. This is also a significant issue. We're not correcting for it. The users are just made aware of it, and they can do their own correction. Coming to the summary, because I realize time is flying, we have and what it actually means, what I've been saying. So we have this new imaging sounding capabilities available. We have some impacts of the Nordic dimension that I just mentioned, but let's not go through them. Now, one thing is the missing daylight also, by the way. In winter, we do realize that, which do affect the visible channels. Some rule of thumbs are with LEO, which is definitely aimed for the numerical weather prediction, NWP, which is important for Finland in a kind of a secondary way, because we're all benefiting from it. And GEO is definitely aimed for the no-casting. But this is all complementary with LEO and GEO. You can't really take one for the other, or just choose one or the other. They are both needed, and they have significant improvements also for the Nordic countries in this kind of complementary mode. I think I finished there because I'm really running out of time. So please talk to me afterwards if you have any questions, because I think I only have 1 minute left. Thank you.
Thank you very much, Jochen. Thank you very much. And dear audience, so you can directly contact Jochen, or you can also send a message to entire conference community and ask questions. So I propose that we are moving forward, and the next presentation is coming from Finnish Meteorological Institute by Ari-Matti Harri, but behind of this presentation is also a larger community. So Ari-Matti, are you already online?
Here we are, Jan. Thanks.
Excellent. So you can start to share your screen and get online.
Okay, let's try. So then this here. I hope you can see this now.
Excellent. We are seeing the slides very well. So
Yeah.
Go ahead.
Right. So I'm Ari-Matti Harri from the Finnish Met Institute, and I'm now talking on behalf of the Pegasus Consortium. It's a global space weather service center designated by ICAO. So we all know regular weather that's caused by the sun on the first tens of kilometers, or let's say troposphere. And now then space weather is also caused by the sun, but now on its influence on the upper atmosphere. And now we talk about ionosphere, magnetosphere, and thermosphere. And today I'll talk about how the Pegasus Consortium is helping to mitigate the effects of space weather on aviation. And the Pegasus comes from the words Partnership in Excellence for Civil Aviation Space Weather User Service. So this kind of acronyms, there are many of them, but this is ours. And some of you may recall that in the beginning, the first words were pan-European, but we changed that to this Partnership in Excellence and maintained the Pegasus name because South Africa joined us, or South African Space Agency joined us, and there are also other organizations beyond Europe who are affiliated to us, and they may be joining later. So we talk about Pegasus, and on the website pegasus.org or pegasus.eu, you can find pretty good picture and descriptions of our consortium and what it does. So we were designated by ICAO in November 2018, and the operational work started in 2019 and 20, in principle, officially in November 19. And our center, or our global service, it includes officially 10 member countries, and it's led by Finland and Finnish Meteorological Institute. The overall aim is to improve aviation safety and efficiency, and that is the ICAO's overall objective. And ICAO has defined for us those impact areas that we need to work on and on which we need to give out so-called advisories that are helping aviation stakeholders to cope with space weather effects. And those impact areas, they are over the horizon HF communications, then radiation levels at high flight altitudes, and then quality of GNSS navigation. I also mentioned here SATCOM, but it's not yet defined by ICAO, but it will later on. The impact areas of space weather that are really of the interest for aviation. Well, firstly, we can talk about radiation at flight altitudes. When sun is affecting the upper atmosphere, it may also cause increased radiation levels. And now, especially on high altitudes, and especially for those flights that go over the poles. And now we talk about accumulated dose for air crew because they are flying a lot. Then GNSS navigation. So space weather may cause errors in positioning, and then also loss of lock through scintillation of the signal amplitude and phase, the same similar way as twinkling of the stars. So these are two major modes of let's say, two modes imposing lower quality for navigational services, and they are very important for aviation, of course. Then disturbances in HF communication. Now we talk about over the horizon communications. So anomalous propagation, and then also variation of the electron density of the ionosphere is also causing, so that it means that we need to use different frequencies. So we need to change frequencies to get good communications, and this is another mode of disturbances. And about SATCOM, those definitions are not yet there. Very shortly about space weather effects themselves. So we know that normally sun is it's blowing from the sun all the time, so solar wind is always there. That is sort of like the baseline situation. But then sun is having disturbances and increased activities, and that will cause additional effects on technological systems. We now talk about aviation, and then we also talk about satellites. So satellites may be also prone for space weather, and then also systems on ground. So electric grids, gas pipelines, and so forth, all conducting networks. So now sun is sending bursts of energetic X-rays and extreme UV, and those will hit us with the speed of light in 8 minutes or so. Energetic streams of energetic particles, it takes a few hours. Then coronal mass ejections, it may take from 15 hours to 2 days to reach us, and then the effect may prevail for various hours, or even for even one day. So that kind of effects we are facing, and they will cause those disruptions that we just depicted. So mainly HF communication disturbances, GNSS quality, and then also radiation levels of flight altitudes. So there are various aspects that we look at the sun, and we make observations from satellites, and we make observations from the ground. And there will be more later on in our presentation on those. But all of this, how to mitigate the effect of sun on aviation and also other systems, it is based on observations and empirical models that are building on those observations. That is the big picture of all of this. As to Pegasus, so we are now issuing advisories when needed, and the way we operate is that we do have got this large 10 member countries wide consortium that are collecting data, digesting the data, processing data. We are generating the advisories, and finally those advisories will be checked and approved at the Pegasus headquarters. That's on the 4th floor of FMI, and on the left pane here you can see the couple of our space scientists who are just discussing about on the space weather situation at our headquarters at FMI. So how to get the advisories, how to generate them. So as I mentioned, we have these 10 countries working on together. So we do have got expert groups that are working on observations of the sun directly and solar physics, working on digesting the radiation levels, working on digesting the over disturbances on over the horizon HF communications, and also working on the GNSS navigational disturbances. And when those results are done, they are flowing into the advisory production hub in the middle of this diagram. That is run by our Belgian colleagues and at STCE, and the advisory production is done in collaboration mostly with the Belgium's and FMI and UK Met Office. When the advisories on space weather for aviation, when they are drafted, they will be sent to Pegasus main headquarters at FMI. They will be checked and then often iterated with the STCE team and finally approved, and then they will be disseminated to the ICAO network. It's a global network that will reach all the civil aviation stakeholders globally, and then that's the way to inform all the stakeholders. Now, I was talking of Pegasus. I should mention and need to mention that now we do have got ICAO designated actually 3 global service centers. Firstly, Pegasus, then NOAA Space Weather Prediction Service, and then also thirdly, ACFJ consortium that's caused by Australia, Canadian, French, and Japanese organizations. So originally ICAO was to designate 2 services working in tandem, but for various political reasons, finally they designated 3, and that's where we are. So the first year we coordinated our efforts and we created a system to work together. Now we are taking 2-week shifts, each of us, and there's a on-duty center that is on duty. There's a backup center and then secondary backup center, and this will rotate, and it works very nicely. We do have got a common coordination committee that is meeting every month or so, or originally every couple of weeks. It's led by myself and Brent Gordon, who is the head of Space Weather Prediction Services Consortium, and that is good way to coordinate things and to make sure that everything works nicely, and we are on good track. So, and we have been there almost for 2 years now. I will very shortly go through this before I need to stop. So the over the horizon HF service, it's based on various observational networks as all of these advisories. But now here, KP index, so that's a planetary geomagnetic activity index, ryometer data, then direct X-ray flux observations from GOES satellite, and then ionosonde network. So all of this, out of this, we will digest and bake out our internal recommendations for advisory, and then it will be finally digested to an official advisory or not. The same ways for GNSS navigational services. So here it's based on ground observations of very, very wide network of traditional GNSS receivers working 1 Hz frequency, and then for scintillation, we do have got some 10, let's say 20 tailored GNSS receiver stations that operate at 50 hertz frequency, and they are able to tackle and take a grip on fast variations of the ionospheric electron density, and that way on this possible scintillation effect. And for the radiation levels at flight altitudes, we are using the Avidos Inc. from Austria systems and tools. Here we can actually see a nice map showing it's a global map showing on the red there's an alert, and then on green is green and yellow is in between. Similar kind of maps we produce for all the advisories, even if then the official advisories are both also text based. Product verification.
Okay, thank you very much, Ari-Matti. I'm really sorry of the very tight schedule here. So
I'm done.
Maija Lönnqvist is already waiting for her turn to start the presentation.
I'm done.
So if you
Thank
have any questions to Ari-Matti about Pegasus system, then please contact him on the chat. And I'm really glad to see that Finland is taking lead in many areas of the space technology and space services, which are truly global. But thank you very much, Ari-Matti, once
Thank
again.
you.
And Maija Lönnqvist, are you already online?
Yes.
Excellent. So the next in the program is the last presentation in plenary session. This is about Finnish Space Administration, and Maija will tell what is Finnish Space Administration and how we can connect this administration. So the floor is yours, Maija.
Thank you. I hope you can all hear me.
Yes, we can.
Perfect. Thank you. Good morning on my behalf as well. I am Maija Lönnqvist and I come from the Ministry of Economic Affairs and Employment, whereas I'm a team leader of our space team, our little Finnish space office. And I promise to tell some words about space administration and Finnish space strategy, its priorities and implementation. And I would like to start with congratulating Aalto University and Kauppakorkeakoulutuskerho and all their partners for the great participation, great amount of participation in this event, and so many speakers, so many companies, research organizations, expertise and innovations. And this actually reminded me of a little conversation I had a few weeks ago with a friend of mine from high school who I hadn't seen for years. So I told her that I work with space policy, and she was very surprised. She said, well, Finland and space. I didn't realize Finland has anything to do with space. And now that I look at a list of speakers and list of all the different things that's happening in the Finnish space sector, she really was wrong. Finland has much to do with space. So congratulations for that and for the great event. So I will begin with a picture of the Finnish Space Administration, Finnish space governance. As you know, we don't have any space agency in Finland. We have many ministries, many agencies contributing to the Finnish Space Administration. But the Ministry of Economic Affairs and Employment has the overall responsibility for the space policy. And since 2 years, we've had the space team acting as the Space Office of Finland with the role of coordinating the Finnish Space Administration. In this coordination role, we act as we head the Secretariat of the Space Committee. We coordinate international collaboration and also aim to take better stronger role in communication. We also have some authority tasks of space activity authorization and legislation on our own, but our main task is to coordinate the administration. While we have the coordinating role, there are several other ministries working with space issues related to their own policy fields, and several agencies working with space in their own expertise areas, such as Business Finland for funding and networks, or Traficom for frequencies, navigation, and so on. And all these different ministries, agencies are brought together with science and research and business enterprises as well in the Finnish Space Committee, which has its role to decide and define the cross-administrational space issues in Finland. Most importantly, the Space Committee ensures the implementation of the space strategy, which I will say a few words further, sets up the priorities of the international collaboration and finds ways to foster the opportunities of the space sector. The Space Committee has the Secretariat for more operative collaboration, and then also 6 working groups together on expert level on 6 different teams. And through this,
Maija, can you
yes,
change the slide? We can only see your first slide at the moment. Actually, we see your presentation overall, not in presentation mode.
that's interesting. Okay. And now you see what?
PowerPoint, just a window. So I think it's when you open the presentation, it makes another window. So it shows only the background, the PowerPoint window, not
So you
the
cannot see
presentation.
any slides.
We
No,
see the
by way,
editor, slide editor.
we see the slide, but I think you can carry on with this, but please click on the left side panel, the right slide, so we can see it. So we now see the slide with the Finnish space governance.
Yes. Well, that's the right one. Okay. But I cannot change to the slide.
Yes, we are seeing the sort of preview window, not the presentation window, but it's all right.
Okay.
Go to presentation mode with the PowerPoint. Press F5.
Yeah, but it might be in the wrong screen, so this is probably the problem.
Okay, maybe I'll just continue with this.
Yes.
Okay. Yes, so then I jump to the next slide. I assume this is because we are the Chrome, not the app. Okay, but just a few words about the Finnish space strategy, which was revised in 2018 and has an ambitious goal to make Finland in 2025 the world's most attractive and agile space business environment, benefiting all companies operating here. And the strategy has 3 themes: prerequisites for entering the market, international impact, and top-level research, which all have several concrete measures and concrete goals that are implemented in order to ensure that we will reach the vision by 2025. And as I told, National Space Committee ensures the implementation and sets every year the priorities for the strategy. And for this and last year, we have 6 priorities: sustainable use of space, a stronger impact in EU space policy, green and digital transformation, security, recognizing future technology and user needs, and capacity building. And just to give you a few examples of how these priorities are implemented, which will be the most important things and measures this year or last year, I have on the right-hand side just named a few of the topics that are important. And as I have only 5 minutes left, I will just pick a few of them. In the first column, you see funding organizations. And as you may know, in ESA programs, Finland is funding that, so that Finnish organizations can participate in ESA programs and projects. And 2019, for the present program period, Finland increased the funding for ESA by almost 50%, from 19 million to 28 million this year. And we have had quite an increase in the interest and participation in ESA programs, and we have also achieved the goals of how much we get from the funding back to Finland. So for ESA program situation is quite good at the moment, but we already have our eyes in the future. So next year's November, Finland will make the next subscriptions for the next ESA program period. And the preparation of this has already started in close collaboration with ESA as well as our own space sector. So the aim is to ensure that we reach the strategy priorities and that we can foster Finnish space sector participation in ESA program also in future. And the second box is about EU space program, and as you can see, our one priority is the stronger EU impact. EU space program started this spring, and it combines the previous existing programs of Galileo, EGNOS, and Copernicus with the newer programs of space situational awareness, as well as GovSatcom. There are also several other initiatives by the European Commission, including space traffic management and secure connectivity, as well as a space enterprise fund called Cassini. And the overall goal of the stronger EU impact is to ensure that Finnish space sector can participate as well as possible in the EU space program and all the other space policy initiatives of the Commission. Horizon Europe is one of the measures as well. And also the public regulated service implementation will bring important possibilities as well. At the same time, there is also in the process the mapping and possible pooling of the Finnish capacities of space situational awareness, bringing them possibly together as a SSA center and making it possible to also participate in the EU SSA program. And as a framework for the space sector, I also wish to mention our space activity authorization, which I also speak later, allowing the Finnish satellite operators to have their needed licenses in order to launch and operate satellites on orbit. And at the moment, we have 16 Finnish satellites in the National Space Object Register, which is quite an increase since 2017, when the first satellite was launched. And as well, there is a project on regulating the satellite data ongoing, and this is in the process and will be finalized later this year, early next year. These are the main messages from the Space Administration I wished to bring you. You can find more information in spacefinland.fi as well as the webpage of our ministry. Thank you.
So thank you, Maija, very much, and let's have a small discussion here. I will invite you right away to wait a moment. I try to get you on the screen. Right, just a moment. Takes a bit of time, sorry for that. All right, Maija. Glad to have you here in the panel as well. So, as you were telling, the ministry, we don't have a space administration like a separate entity, but ministry, however, regulates and is responsible for all the satellites, and the government is responsible for all the satellites which Finland has. So can you tell a little bit more how this actually goes, and if I'm building a satellite, do I need a license or something?
If you want to build a satellite, you don't need a license, but if you want to launch it to the space, you need a license.
Okay, and that means like whoever is working with a satellite, it might be a secondary school, a university, and the satellite can be as small as it can be, maybe as a matchbox, but you still need a license because the government is responsible for your satellite.
Yes.
Exactly. So this is especially important for CubeSats and all the other satellite builders, that we are following the rules. There are a couple of rules to have a permissions with. We need a permission for launching the satellite, operating the satellite, and also for the radio frequencies. And today, Maija is going to give an overview in interactive session, and she is available also here, so please ask her. And she's giving a presentation as well about how to apply and when to apply your satellite permits. So this is really important because Finnish government and the taxpayer is, by the end of the day, responsible for all the satellites which has been launched under the Finnish flag. So that's why it's important to also follow the rules. Am I right, Maija?
Yes. Yes, this is why I wanted to just give a short presentation later this afternoon, because I know there are several active companies based also on the presentations I can see on the program. There is a great interest on CubeSats in Finland. So it's just important from the beginning to understand that you need authorization before you can launch the satellite to the space.
Exactly. And we have another interesting session with Maija today as well. Kari Luojus has been agreeing with Maija. We are going to talk about Finnish astronaut. Are we going to get the Finnish astronaut? Is it really possible to have a Finnish astronaut? How to should we pay for a Finnish astronaut? All these questions are going to be online in the main track of this program, which is broadcasted as well. right after 3 o'clock when we going to start with other sessions on the breakout rooms as well. But thank you very much, Maija, for this a nice short interview here. We're going now further with our program. And next in program, we have a short break where we're going to introduce what's happening next. And what is happening next is we're going to have a little break, 10:30. We start with actual sessions. We're going to have 3 different sessions starting. One is Arctic and Boreal, another one is CubeSat missions, and there is also session for space education. All these 3 sessions have 4 presentations. So I'm also going to show you very quickly what kind of presentations we're going to have. So the first session is Arctic and Boreal session. We have a presentation about methane observations from space. We have ESA snow product presentation by FMI, spectral characteristics of the understory, and then we have also a presentation about Cryosat, Cryosat 2 and SMOS merge sea ice thickness measurements and interpretation. The second session is going to be a CubeSat mission session. We have news from Suomi 100, Suomi 100 Space Weather CubeSat. Esa Kallio is going to tell about this satellite. Then we have a very interesting presentation about the first wooden satellite in the world, and of course it's coming from Finland. Then we have a presentation about hyperspectral CubeSat called Hybris, and how this works with in synergy with different bigger missions. And then last but not the least presentation in the CubeSat missions is Kvarkensat, a Finnish-Swedish CubeSat, and the presenters are coming from Kiruna. And as you observed, we have actually the whole track today about CubeSat presentations. So we are having CubeSat presentations in all 3 parallel sessions throughout the day, and also in an interactive session. So these are the sessions which are coming, and then also the space education session. We're going to have a very nice presentation about ESERO network. I'm really glad that Finland has finally joined ESERO, and with its own ESERO spot here in Helsinki, or actually Vantaa, it's in Heureka. Then we have a Giron Space Organization, which is telling how things are organized in northern Sweden. We have an interesting talk about Project Raven and how it has been dealing with the COVID situation. And then we can get also an overview how the national space sector is supported and managed in Hungary. So these are the sessions. You can join the sessions by joining breakout rooms. You either have on the toolbar a breakout room tab, which is Windows logo-like icon, or then you have 3 dots and more. And then this more icon will take you to the breakout rooms. And you have a list of breakout rooms. So let's see, has Suvi already been starting to create the breakout rooms? And here on the main channel, we are going to have a bit of videos about our partners and companies. And perhaps we're going to have also a discussion about some topics online. So stay tuned. If you have any questions now, feel free to ask right away. apparently we don't have any questions, so we are going to go soon to breakout rooms, but before that we are watching some videos, and you can use the time to make a coffee or similar. So see you soon, and I hope you will find a good presentation in the breakout room. We also creating a special breakout rooms for discussion. So if there is really your presentation is too short and you are not able to perhaps cover it entirely, or something will go wrong, then what I recommend is go to the breakout room, get your audience to the breakout room, and use this channel for chatting about your presentation or answering the questions. Also, let's see what other technical news we might have. It seems like the platform is so far working pretty all right. We are getting forward with that. Next sessions are going to be Arctic and Boreal, CubeSat missions, and space education. And here you can see also a video of HARP Technologies. We're going to have these videos also on the, or we already have these videos on the web page of the conference, so you can take a look anytime how this will work and what kind of companies we have in Industry Hour. So in Industry Hour, it starts right at 1 o'clock and will last till 2 o'clock. And during the Industry Hour, you can go and meet online with all our industrial partners. So every company will have their own breakout room. So soon we are going to start with sessions in breakout rooms. I hope everybody are already going to their breakout rooms. The breakout rooms are already opened. I see how people are already joining the breakout rooms. So we're going to have CubeSat missions, Arctic and Boreal session, and also space education session. And here in the main channel, we are going to follow the videos and see what is happening in breakout rooms. So I wish you everybody a very nice sessions, and let's get back here to the online channel approximately 11:45. So I really wish you have nice sessions now.
Humanity. The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite, and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks
to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth regardless of what's happening underground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat, and we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään semmoista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin oli Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatioon, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyy käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of like humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. To see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before.
So everybody, feel free to join breakout rooms. All the science sessions are at the moment going on in breakout rooms.
12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea of, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat, and we wanted to make it daily so that every day you can get a repeating ground track image acquisition from the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
For many, it's the sense of freedom while soaring far above the Earth with the horizon the only boundary. But for me, it is something very different, the fascination of landing. When the Earth draws closer and closer, when the distant vision resolves into finer structures and vague outlines become distinct features, when ever smaller details are revealed to the eye. But in the world of the very small, where the human eye is no longer enough, we enter the domain of X-ray and CT technology. Here we make things visible that are 200 times finer than a human hair. Precision is paramount in the inspection of parts and materials, in their exact measurements. Minute defects can have big consequences for the safety of components. That's why every truck tire is X-rayed to make sure it's roadworthy. And every turbine blade intended for jet engines is examined inside and out. Our technology is used to screen the luggage of millions of passengers, and soon this inspection will also quickly and reliably identify what types of fluids travelers are carrying. This is where my colleagues and I are working to invent the future. A key trend in many industries is miniaturization. Far beyond where conventional measurement methods reach their limits, our computed tomography opens up undreamt of possibilities. We deliver razor-sharp 3D views of even the tiniest parts. All details can be measured with the highest precision and compared with CAD drawings, for example. Especially in the fast-changing world of electronic components, wherever greater performance must be packed into smaller and smaller devices. Our X-ray and CT solutions are integral to assuring that every part will be able to perform as specified. A crucial element in all this is the software. The best image quality is only made possible by highly complex algorithms. Yet for the user, the equipment is as easy and intuitive to operate as a smartphone. In the automotive industry, the limits of the possible are constantly redefined. And that begins right in the research labs, where new materials and manufacturing methods are tested. The tailor-made inspection and measurement solutions that I develop together with customers help optimize their processes, make their production more reliable, and save resources. No company can afford to design or deliver faulty products. It makes me proud to know that the largest and most successful companies in the world rely on our technology. Whether it's in the automotive sector or the aerospace industry, in electronics or medical equipment, the applications are practically endless. Seeing everything that's already made possible by our X-ray and CT solutions, I'm excited for the future. I'm eager to see what new worlds our technology will bring into focus next.
Interference-free satellite positioning is vital for the critical functions of society. Our researchers have developed a public GNSS signal quality monitoring service, GNSS Finland. This state-of-the-art system produces data that can be integrated to other situational awareness systems. Want to know more? Join us at our virtual meeting room.
We are living in a connected world. We are operating in a global economy. We are embracing digitalization in a fast-paced society. Communication, mobility, security, science.
Liftoff.
Life on Earth advances thanks to space technology. RUAG Space is the partner of choice for manufacturers of satellites and launchers across the globe. Enabling society to prosper, advancing everyday life. Today and tomorrow, we make it happen.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency, and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives, Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So, Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
Time and time again, people have been gazing up at the night sky, looking for understanding and answers. But what if the answers might actually lie in the constellations staring back at us? Hundreds of kilometers away, small satellite constellations observe the whole wide world. Despite the distance, these satellites can be harnessed to satisfy our need for instant, reliable information and to benefit everyday life on Earth. Everything from national security to nature monitoring can be improved with space technology. We can now use remote sensing for blue-green algae monitoring in near real time, or rely on satellites to provide fast and robust communications during national security emergencies. At VTT, we believe space technology to be the answer to many of the pressing issues we face today. That's why for decades now, we've been working in space innovation together with our key partners, such as the European Space Agency. We have created the world's first hyperspectral cameras for small satellites and the first W-band millimeter wave radios operating in space. For us, it's not just about exploring what's out there. Our bold vision is to make space technology an integral part of the day-to-day life on Earth, with technologies like beyond 5G, hyperspectral imaging, and Earth observation. Want to join us in making a difference on Earth and beyond?
We have been on the far side of the moon.
So, welcome back slowly to the main channel. I think most of the sessions are still wrapping up, but we are starting to prepare already for the next session. So we have people online here as well. Is there anybody who has been having troubles to joining the sessions or having any other type of feedback, recommendations, observations, anything? So let's then wait a couple of more minutes. The session rooms will close 11:35 and all the people will come back to the main room then, and we are able to then create new sessions. Welcome back to the main channel. I hope the breakout rooms starting to be ready. The sessions are listened. We are starting to prepare for the next sessions. So do we have anybody online who could comment the sessions, so how it went?
Hey, Jan. I can comment on the CubeSat session. It was really nice. We were lacking one talk. Don't remember the title, but Alessandro, something like that.
Yeah,
but there were really good. There were really good talks about Suomi 100, wooden CubeSats, QuarkNSat, and so on. I really enjoyed it. Yeah.
Excellent. So technically, it actually works. So Johanna, are you online already?
Hello, I'm online.
How did Earth observation Arctic and Boreal session went?
Hello. Yes, we had a very nice session. Slightly technical problems at the end, but anyway, there were backup people who catched up nicely.
Excellent, excellent. I really recommend to everybody that please go to the testing breakout rooms and then learn how to go to the breakout room, how to present your slides. It takes you 5 minutes and we will save the sessions. I'm really sorry that we have so short presentation format, but on the other hand, if there are technical problems, we are not wasting too much time. So Johanna, thank you very much. I think we are now starting to introduce the next sessions. We have a next session block of 3 sessions coming up very soon, and starting 11:45 we have 3 sessions. They are called Earth Observation for Society, Student Missions and Missions. And let's see, can I find the right slides here? So in first Earth Observation for Society room, we're going to have about discussion or the presentation about crowdsourcing given by Timo Pyhälahti. Then we're going to have another forest presentation which is given by Tuomas Häme, Forest Flux, developing operational Earth observation services for forest users. Then we have a presentation about Tarkka, web map application by Hanna Alasalmi. And then we have also a presentation about forestry TEP by Renne Dergujev from VTT as well. We have an interesting mission or session coming about student missions. We have a presentation about MOVE satellites. These are coming from Munich University or Technical University of Munich. Marius Anger is going to present this project. We have a status update about Project Aptas, Kiruna Student Satellite Project. Then we have about Project Aster, which is another Kiruna-led project by Peter Hemström. And finally, we have also an update about EastCube 2 mission by a team from Tartu. And I think Janis Dalvins is going to present this presentation. Then we have another session about missions. Unfortunately, we were not able to put all these different mission presentations after each other, so we had to create some parallel sessions as well. But there is extremely interesting proposals and ideas about missions. For example, Mikael Granvik is going to tell about Icarus mission. Then Neha Gohan is going to discuss the Reorbit's Ukko mission, a precursor of their commercial missions. Then we have an idea of multi-agent rendezvous with small solar objects given by Adita Savio-Paul. And then we have a flexible LEO platform for new space applications by Jens Eickhoff. So these are the sessions which are starting in 5 minutes. I think the session rooms are going to be closed and reopened pretty soon. I think they are already open, so you can go to the sessions and see what happens. Another announcement which I would like to make also here is that unfortunately Vytenis Busas from Lithuania, Nanoavionics, has to cancel his presentation in the evening plenary session about nanosatellites. So if there is a good proposal about a plenary session talk at 12:15 to 14:15, around 2:30, then you can propose your talk to be in a plenary session in order not to waste time and have something which is interesting for everybody. All right, but the mission or session rooms are starting to be open already. People are going to the session rooms, and also don't hesitate to send me a note or raise up a hand if you have a good suggestions how to make this conference flowing more smoother. But now let's go to the all different. Yes.
Yeah, one small note. In the CubeSat missions, we had a very nice event when we were missing a speaker. Somebody volunteered as a chairman, and we quite nicely and agilely gave more time to Jari Mäkinen. So we were doing exactly what you wanted us to do on Friday when you said that you want this to be very informal and versatile, conference. So let's just not waste time. You can always talk even if you are on virtual domain.
Exactly. And then also, if you need to have an extra session for something, we are happy to create a virtual room for you, and we could have an announcement here in the break moments, and then you can announce your room and the topic and go forward. We already have the rooms for the companies, so the commercial presentations are going to start at 1 o'clock. For those, we don't need extra rooms, but if you have any other ideas or extempore meetings, just let me know. We are creating a room, and then you can start with that. But without longer discussion on that, let's go to the rooms and start with the next sessions, which are Earth observation for society, student missions, and missions. So I hope you have all very nice sessions there.
So yeah, where should we discuss the replacement plenary?
Send me just the private message in the Zoom chat, and we can have a discussion there.
Okay, I sent already. Yep, let's talk there.
Of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään semmoista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin oli Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatio, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyy käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of like humanity.
The globe has always been on the move. Until now,
We really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology is the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
So hello everybody online. I'm just making a small announcement that all our sessions are happening in breakout rooms. New presentations just started in all 3 different breakout rooms. We have a session on Earth observation for society, student missions and missions. All these presentations are given in the breakout rooms, so please navigate to the breakout rooms if you would like to listen to the scientific presentations. Any questions? If you have anything, I can answer right now. So hello everybody, just giving a short announcement that our sessions are happening in breakout rooms. If you would like to see the scientific presentations, please join the breakout rooms. And if you need any advice, anything, just speak up right now and I try to help you. So we have currently Earth observation for society, students missions and missions. And in Earth observation for society, Tuomas Häme is telling about the Forest Flux project at the moment. In breakout room, we have an overview of project APTAS, a student project from Kiruna, Luleå University. And in the missions room, we have a Reorbit's Ukko mission presented at the moment.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
For many, it's the sense of freedom while soaring far above the earth with the horizon the only boundary. But for me, it is something very different, the fascination of landing. When the earth draws closer and closer, when the distant vision resolves into finer structures and vague outlines become distinct features, when ever smaller details are revealed to the eye. But in the world of the very small, where the human eye is no longer enough, we enter the domain of X-ray and CT technology. Here we make things visible that are 200 times finer than a human hair. Precision is paramount in the inspection of parts and materials, in their exact measurements. Minute defects can have big consequences for the safety of components. That's why every truck tire is X-rayed to make sure it's roadworthy. And every turbine blade intended for jet engines is examined inside and out. Our technology is used to screen the luggage of millions of passengers, and soon this inspection will also quickly and reliably identify what types of fluids travelers are carrying. This is where my colleagues and I are working to invent the future. A key trend in many industries is miniaturization. Far beyond where conventional measurement methods reach their limits, our computed tomography opens up undreamt of possibilities. We deliver razor-sharp 3D views of even the tiniest parts. All details can be measured with the highest precision and compared with CAD drawings, for example. Especially in the fast-changing world of electronic components, wherever greater performance must be packed into smaller and smaller devices. Our X-ray and CT solutions are integral to assuring that every part will be able to perform as specified. A crucial element in all this is the software. The best image quality is only made possible by highly complex algorithms. Yet for the user, the equipment is as easy and intuitive to operate as a smartphone. In the automotive industry, the limits of the possible are constantly redefined. And that begins right in the research labs, where new materials and manufacturing methods are tested. The tailor-made inspection and measurement solutions that I develop together with customers help optimize their processes, make their production more reliable, and save resources. No company can afford to design or deliver faulty products. It makes me proud to know that the largest and most successful companies in the world rely on our technology. Whether it's in the automotive sector or the aerospace industry, in electronics or medical equipment, the applications are practically endless. Seeing everything that's already made possible by our X-ray and CT solutions, I'm excited for the future. I'm eager to see what new worlds our technology will bring into focus next.
Interference-free satellite positioning is vital for the critical functions of society. Our researchers have developed a public GNSS signal quality monitoring service, GNSS Finland. This state-of-the-art system produces data that can be integrated to other situational awareness systems. Want to know more? Join us at our virtual meeting room.
We are living in a connected world. We are operating in a global economy. We are embracing digitalization in a fast-paced society. Communication, mobility, security, science.
Liftoff.
Life on Earth advances thanks to space technology. RUAG Space is the partner of choice for manufacturers of satellites and launchers across the globe. Enabling society to prosper, advancing everyday life. Today and tomorrow, we make it happen.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
Space and its technology continue being a key element in our society development despite COVID. At both EAST and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
Time and time again, people have been gazing up at the night sky, looking for understanding and answers. But what if the answers might actually lie in the constellations staring back at us? Hundreds of kilometers away, small satellite constellations observe the whole wide world. Despite the distance, these satellites can be harnessed to satisfy our need for instant, reliable information and to benefit everyday life on Earth. Everything from national security to nature monitoring can be improved with space technology. We can now use remote sensing for blue-green algae monitoring in near real time, or rely on satellites to provide fast and robust communications during national security emergencies. At VTT, we believe space technology to be the answer to many of the pressing issues we face today. That's why for decades now, we've been working in space innovation together with our key partners, such as the European Space Agency. We have created the world's first hyperspectral cameras for small satellites and the first W-band millimeter wave radios operating in space. For us, it's not just about exploring what's out there. Our bold vision is to make space technology an integral part of the day-to-day life on Earth, with technologies like beyond 5G, hyperspectral imaging, and Earth observation. Want to join us in making a difference on Earth and beyond?
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency, and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily, so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
So, welcome back. I think the sessions are going to stop in a few seconds and we are all gathering back to the main session here. And let's wait a couple of more minutes when people are settling back here and we are resuming for the next big event, which is Industry Hour at 1 o'clock. And perhaps before that, I'm going to have a short discussion with Markus about how Industry Hour is going to be arranged.
Hey, Jan, so what do we do with the talk?
Have you been reaching out? Yes, it's possible, but I haven't been seeing your wait a moment. All right, so Andris, reach me out by email just after this intro, and when we will sort this out when the industry hour starts. But,
yeah, that's very good because the Zoom chat disappeared.
Yeah, it happens.
Yeah.
So, but welcome everybody. Welcome back to the main track. And next big event in our program is Industry Hour. And just giving you a short overview what to expect today. More we have Industry Hour. It starts at 1 o'clock and will last till 2 o'clock. And our host for Industry Hour is Markus Hiltunen, and Markus is going to have a constant program throughout the Industry Hour on the main channel. So if you are preparing to take a lunch, for example, you can easily watch the Industry Hour, follow during the lunch what is happening, and we are also encouraging everybody to go to the breakout rooms. So every company has their own breakout room, so you can easily find your breakout rooms and discuss for an hour or any amount of time, which is less than an hour, with the companies. So Markus, are you already online?
Yes.
If you speak up and put your video on, then I probably will get you also on the screen.
I have my video on and voice on.
All right, I will try to find you. It's not so straightforward to find people here. Let me see. Excellent. So we'll make you the meeting host. I hope you are the host now. And Markus, can you invite me to the panel, and let's discuss how this Industry Hour actually will work.
Yes, you would have to make me the host.
So Markus, was I successful with
Yes.
making you host? Excellent.
Yes, you were. Just a second.
So quick note, Jan, maybe you can use headphones because you're producing echo. And if there's a discussion, then it's difficult.
Okay, we are in a very close rooms. This might be a problem.
Like this.
Like this. So our intention is to have a discussion with different industry partners and representatives on the main channel. And Markus is the host of this process. And Markus, who is the next on the line to be the first?
The first company would be CGI, and from there Tuukka Mattila and Sakari Sarjakoski.
Excellent. Tuukka, are you ready already? I hope
Hello,
so.
can you hear me?
Yes, we can. And you are probably the next on the line here on the Industry Hour. And at the same time, we're trying to get quite quickly also all the breakout rooms opened, so that we're going to have also the breakout rooms with the names of the companies. And then you can go after the interview already to the breakout room and discuss with these companies. So any questions from anybody? Mate, I can see you already there, so welcome online, and welcome to everybody. So please don't close the channel during the breakout or during the lunch hour. You can follow the program and you can pick up a couple of topics and then go and discuss with industry representatives. But all right, Markus, are you ready?
Yes.
All right, you can start to fiddle and get the right people online. I'm trying to get the small lines perhaps myself and talk with a couple of companies in the breakout rooms as soon as possible.
Yes.
So, thank you.
Let's see. First, I will have to take Tuukka Mattila here from all of you. Can you, Tuukka, put your camera on and say something?
Yeah, just a moment. So can you see me?
Let's see. At least the Zoom doesn't give me your name yet, so I have to do this manually then. Okay. Okay, now I have found you, and is Sakari also online?
It seems that he's not yet, so maybe in a minute or two.
Okay, just a second. Okay, let's do it like this. Now I have to remove all of you others because for some reason Zoom doesn't want to play with me.
Yeah, so Sakari should be available now. Hello.
Okay.
Can you hear me all right?
Yes.
Okay, great.
Yes, so it appears that Zoom is very doesn't really like us having so much people on. So I have to do this manually and remove all of you others one by one. Okay. Yeah. So well, you can also present your own presentation if you want. Can you hear me?
Yeah, I can hear you.
Okay. So CGI, you are a Canadian IT company. What are you actually doing in space?
Yeah, so basically at the moment we're here. So my name is Tuukka Mattila. I work as a technical project manager in this remote sensing project, and then we have Sakari Sarjakoski, who works as a consultant, so specialist in our project. And do you want to say hello, Sakari?
Apparently
Okay.
he doesn't have his mic on.
Yeah, okay, but we can continue. So basically what we have here, you said that what we are doing in space. So basically we have three sets here. So I'm gonna give you an elevator pitch, and then Sakari will be having a brief remote sensing project presentation, and then just briefly about the recruitment opportunities what CGI has at the moment. So basically, CGI's space and GIS experience dates back to the early 1970s. So for decades, we have been a strategic and trusted partner for clients worldwide that are revolutionizing the space industry. So we have a full range of business and technology capabilities to help each client achieve their mission. And geospatial technologies, including GIS and high-resolution location object data, they have become business-critical capabilities. So basically providing advanced insights and innovative customer and user experiences. So we're a leader in geospatial services around the globe. And we help our clients to create and utilize state-of-the-art GIS information systems to reach the business goals. And since you're interested what happens in Finland, for example, we'll be working closely with the Finnish Food Authority called Ruokavirasto, and then the FMI, Finnish Meteorological Institute, and the National Land Survey of Finland. And one ongoing project example is that CGI Finland has been implementing and further developing Earth observation solutions on behalf of the Finnish Food Authority for agricultural subsidies control in Finland. So basically, Sakari can tell you more about the project here. So,
yes, I should be online now. Can you hear me?
Yes.
Apologies for the connection issues. So yeah, I'm just going to give you a quick overview of the project we're doing for the Finnish Food Authority, since we're really short on time. In a nutshell, we've been developing, as Tuukka said, this system for Earth observation-based agricultural monitoring. And the main objective is to analyze whether individual agricultural aid or subsidy applications meet their requirements. For example, whether the same crop is sown as declared in the application by the farmer, or whether the grasslands have been mowed as required. And the output from this analysis is a so-called traffic light for the subsidy payment schemes, meaning that a parcel gets a green light if it's okay, and the red light if there's discrepancies detected in the application, and then a yellow light for inconclusive parcels or applications that might need further inspection, maybe ground inspection, or so on. And this information is then used by the payment agency, which is Ruokavirasto or Finnish Food Authority, and then also relate to the farmers. They will be notified, especially in cases where action is required from them. And this system is based on extracting satellite observations into time series for each agricultural parcel, and then further analyzing that time series. And currently, we're working on validating results from solutions that we have so far developed or implemented, and also exploring new solutions. I could go on, but I think we're quite short on time, so I'll give the mic back to Tuukka now.
So that was about remote sensing. So as a CGI, are you fully staffed in Finland in your space businesses?
Yeah, so basically we have open positions also for this project. So actually today started one data scientist in our project. So we're currently, I work as a project manager, and then Sakari and 3 different developers. One is the architect, and then we're having now the new data scientist, and then we're looking for more DevOps, software development, and remote sensing specialists. So I would suggest that you come to our breakout room, and then we also have a couple, 2 directors there in separate days, and here's some agenda what we have there. So more detailed presentations about the project and etc. You can ask questions and so forth. Thanks.
Okay. If that's what you have, then we can move on. Let's see. Now. Next on my list is IRF Space Lab, and they're Mette Kernei, or Kernei.
Yes, good afternoon. Mette Kernei from the Swedish Institute of Space Physics.
Did I say your name correctly?
Yeah, close enough.
Okay. Okay, let's see if I can find you from this list. Like that. Okay, now I found your name, and then I have to. The Zoom is having really making my life difficult currently because of our large number of guests, but I think I can just manage now. Like this. Mete, can you wave your hand?
Yes.
Do you have your video on?
Yes.
Okay, so it appears it's again Zoom didn't take you this time to our immersive view, which is for some reason it doesn't let me manually choose who to take with me. Do you see yourself in the view currently?
I see the Satellite Workshop logo in the middle.
It's very difficult now. Okay. Okay. Can you see your own picture?
No.
I believe you are one of the two black boxes I have over here.
At least I can see his image when using the gallery view, but not in the speaker view.
Okay. Oh, there I found. Now I see you. Okay. I am sorry for this. We tried to we practiced this whole setup yesterday, but Zoom doesn't let me manually pick out all of you, and I believe it's due to the large amount of guests we have currently.
So I'm not that beautiful anyway.
What?
I'm not that beautiful anyway.
No, I think this is okay. Now this is starting to look like what I had in mind. Okay, well, we have time and hopefully we get better at this, or I do. Okay, so IRF Space Lab, who are you?
Yeah, so IRF stands for the Institutet för Rymdfysik, which is Swedish for the Swedish Institute of Space Physics. So we are a governmental institute, and we have been developing particle detectors for space-based applications, so satellite payloads, essentially, for over 50 years. And we are based in Kiruna, northern Sweden, and we are developing these instruments here from the very beginning. So we do the whole process. We do the design, manufacturing, assembly, and then the testing, everything in-house. And you might ask, what are we doing in this industry hours? Well, we have our testing facility called Space Lab, IRF Space Lab, and we are in the process of opening up for external users. And we are trying to be a test service providers and open our free capacities to commercial customers.
Okay, that's very interesting. And like the location of Kiruna, where you mentioned you're situated, that's very interesting location for a,
yes,
like a high-tech company.
Yeah, space industry here in Kiruna is expanding rapidly now, mostly because of the Esrange Launch Center, and they are planning to. They are doing a lot of rocket launches and balloon launches, and now they are converting the base into a orbital launch facility, because so far they've been doing this sounding rocket experiments here, but now they will also launch to orbit. And obviously we are targeting the users of these rockets, so people who are developing payloads or satellites and they can come to us and test their equipment if they wish to.
Yes.
But we are also, Kiruna is actually a really nice touristic location as well. So if you wish to combine your work trip with something exciting, then we have Northern Lights, reindeers, noctilucent clouds, whatever you like.
Yes. What kind of testing services do you have? Like I've been involved in some space projects myself, and I have to say even the facilities required for testing space equipment, that's pretty intense, and they are quite expensive. So what services can you provide?
Yeah, so currently we have several TVAC chambers, so you can do thermal vacuum tests. We have a vacuum chamber which is able to provide solar balance tests. We have a small shaker for mechanical tests. We have a bake-out chamber. We have calibration facilities, so a particle accelerator with an electron source, which we can also convert into neutron source. So currently, these are the available facilities. For the commercial users, I think it's the thermal vacuum, the solar balance, and the mechanical tests, which are the most interesting. But you have a complete list of our equipment on our website, spacelab.irf.se.
Yes, that's quite interesting. So is this, or what are the future plans? Will you expand your portfolio, what you are doing in space businesses?
Yes, so we are expanding the lab itself, and right now in the middle of a development of our shaker facility. So we are planning to buy a larger shaker, which is able to provide mechanical tests for payloads up to 100 kilograms. Well, it obviously depends on the frequency range as well, but it will be a larger shaker. And the specialty with this one will be that it will be placed in a clean environment, in a clean tent. And for us who are developing very sensitive sensors, it was always a problem to test our instruments, mechanical tests in a clean environment, because usually we go to a commercial service which is not that clean. But we are planning to do ISO 6-7 environment even under the mechanical test, so that will be a very unique. Then we are also upgrading our solar simulator, which is able to providing a solar balance test, and we are moving the cobalt 60 radiation source from Uppsala to here in Kiruna, and it will, so you can do total ionization dose tests, so radiation tests for electrical components here at IRF Space Lab. All these upgrades will be published on our website once it's operational. For the cobalt 60 source, the timeline is approximately end of this year, and the clean shaker will be available from, well, depending on delivery time, but I would say Q2, Q3 of 2022.
Just out of curiosity, you mentioned you are having a cobalt source. That's sounds like a equipment and capability that is like on paperwork and side very, very difficult to obtain. The jurisdiction must be quite heavy concerning that.
Yes, we had this source in Uppsala for a long period, but we are lacking competence and personnel, because the person who used to operate it is retiring, and they were thinking about decommissioning the source, but we said that we would like to have it here in Kiruna because there is a demand for it. And yeah, it was a lot of paperwork, but we are going through it, and the plan is again to have it operational by the end of the year.
Okay, that's interesting. The set of testing facilities you have, it seems to be quite large. But thank you for this.
Yeah, thank you very much. And if you have questions, you can find me in the breakout room, or you can visit us at spacelab.irf.se.
Yeah. So Space Lab.
Yeah. Thank you.
The next one would be UP42 and Bertrand Saint-Guillain.
Yeah, I'm here. Hello.
Hello.
Can you see me?
Yes, I can. And now Zoom is playing nice with me and showing you directly.
Perfect.
Okay.
I'm
So
very
it's
happy.
significantly less painful than last time.
Excellent. And thank you for spelling my name perfectly. It's Bertrand Saint-Guilhem.
Let's try again. Bertrand Saint-Guilhem.
Exactly.
Okay, nice. That's French?
Yeah, I'm French.
Okay, yeah. I don't speak French, and that's purely accident. I can say your name so well. So, what's Up42?
Yeah, Up42 is a German company located in Berlin. And Up42 is a developer platform and marketplace to derive insight from geospatial data at scale. So the idea is really to facilitate the access to geospatial data and to geospatial algorithm and to scale. So really to think big and to be able to run a huge amount of workflow on the infrastructure.
Okay, so you are like a subsidiary of Airbus.
Yes. So Up42 was created in 2019. We were created by Airbus. We are 100% subsidiary of Airbus, and we were incubated by BCG Digital Venture. Currently, we are 55 people in Berlin.
Okay, 55. That's a moderate size. So what kind of data are you offering? You're a database company after all. What kind of data are you offering and kind of analytics?
Yeah, so what we are including under the geospatial data is not only satellite images. Of course, we have a lot of satellite images, but we have also aerial photography. We have also elevation data like DSM, DTM. We have weather data. We have IES data for maritime applications. So it's a wide portfolio of geospatial data.
Okay. So for all kinds of geospatial applications.
Yes. But of course, the main focus is satellite and aerial. So something visual.
Okay. Are you in the business of just providing data, or are you in the business of providing also solutions to use that data?
So we are not only in the business of data, so we are offering on one side the data, but the idea is to combine the data with analytics, right? Analytic can be pre-processing analytic or vegetation indexes like NDVI, ABI, but also a little bit more complex analytic like machine learning and analytic, for example, change detection, object detection, like car detection or truck detection. So it's really not only about data, it is also about the algorithm. But we are not also completely in the business of solutions. So what we offer are ready-to-use data and analytics blocks. We are not starting to do a custom solution with a recommendation. That's not the idea. The idea is really to provide tools to simplify the access to scale with those so-called ready-to-use data block and ready-to-use analytics block.
Yes. Okay, that sounds quite. How should I say it? A large set of the pipeline you're offering. It's quite big.
Yeah.
So this is so satellite images are obviously the main source of data. Are there anything else but satellite images?
Yes, for example, something really completely different is IES. IES data are very important for tracking ship, vessels, big vessels, and this has nothing to do with satellite images. It's signals sent by a small box on each vessel.
So like the.
Hello. Yes, hello?
I think we lost Marcus now. I don't hear him as well.
Yeah, yes. So I think Marcus wanted to ask me what are IES data. So these are the data that each big vessel would send. So like position, port of arrival, destination of arrival, estimated time of arrival. So there are a lot of attributes, maybe it's 25, 30, which are very important to qualify each vessel. And the idea is that so to give access to the AES data, but also to combine them with satellite images, for example, in order to detect black vessels, so ships which switch out the AES signal. So if you combine a satellite image with all the AES data that you are supposed to receive, you will see that maybe a few vessels have switch off the AES signal. So that's an interesting application to detect black vessel. Hello, Marcus, are you online? Marcus. No, I think there is a problem with Marcus. Marcus?
Oh, he's definitely offline. I think we...
Can you see or hear me again? Yes.
Ah, yes, excellent, Marcus. Hi, hi,
Jesus.
hi.
My okay, my computer did something just then. Sorry for leaving you hanging. Again, we are not free of all these interruptions. Okay.
So during your interruption, I explained what is AES data and why we are offering this kind of geospatial data, which are really interesting for maritime application.
Okay. Okay. So based on that, I think. So you mentioned you have like machine learning or machine intelligence solutions. Like, did you explain any of those when I was fixing my computer?
No, not really. I was continuing to explain AES data, but let's speak a little bit about those more complex algorithms. It can be object detection, like tree detection, or car detection, or truck detection, or swimming pool detection, or also change detection. And those algorithms are not our algorithm. We are partnering with specialists worldwide, which bring on our platform their expertise as in a form of a ready-to-use block, right? We are not consulting company. They have to put on the platform a block dedicated to a very specific task. And the idea is that we will be able to automate and to scale to repetitive tasks on our infrastructure. Of course, an algorithm will always work best where it was trained. So a tree detection, if it is trained over Europe, will work best over Europe. It will work differently over South America, for example. That's something that is always described in the block on the marketplace. So before you start running and selecting the corresponding satellite images, it's important to have that in mind.
Okay, it's interesting. That's pretty good coverage of what you do at Up42.
Thank you, Marcos.
And thank you for participating. Next is Perttu Yliopas present here of Aurora Propulsion.
Yes, hello.
Yes, hi. So I think I understood that Aurora Propulsion is a little smaller company than Airbus. At least.
still for a while, not quite there yet, but hopefully in a few years. We are reaching that.
So maybe we have to explain what is Aurora Propulsion.
Yeah, so Aurora Propulsion Technologies is a Finnish startup. I'm the CTO and founder. We founded almost exactly 3 years ago here in Otaniemi. And we have about 25 people on board right now. We do propulsion systems, mainly focusing on Resistojet technology, which we've developed for both orbital changes as well as attitude control, as well as the plasma brake, which of course much of this audience is familiar with. We have our first in-orbit demonstration satellite, the AuroraSat-1, flying end of this year, where we have both a 6-thruster attitude control system using water resistor jets, as well as 2 plasma break units, just for redundancy, that we are going to test on orbit for the first time. It's a 1.5 unit CubeSat, so it is quite a compact form factor for 6 thrusters and 2 plasma breaks.
How many units?
1.5. 1.5 units.
So less than
Yes.
2 units spacecraft and CubeSat, and you have how many thrusters?
6 thrusters and 2 plasma breaks.
Okay, that's thrusters per volume is quite high there.
Yes. Yeah. So we can basically put a large number of these resistor thrusters into a single integrated system. They are basically the size of a tip of a pen. That's basically the size of a single thruster. So we can configure them to almost any directions. And we are not only looking at attitude control, but also full 6 degrees of freedom movement for near future.
Okay. So that's a nice overview. Is there what kind of product lines do you have? You have resistor jets and you have these plasma brakes. I believe the plasma brakes are still to be demonstrated.
Yeah, so of course, as many of you here do know, the plasma brakes have been flown on SCube-1 and Aalto-1, but the deployment system is very difficult to do, especially in this kind of form factor. So there hasn't been still any actual deorbit rate or force measurements from orbit. And hopefully we will get some, and hopefully the upcoming satellites of ForeSail also will be getting some results, so we see whether the technology really is viable for large scale usage. And we do have a little bit different approach than the Finnish Meteorological Institute, but we are also doing much collaboration with them, of course, because it does make sense to collaborate on this kind of technology development. We are looking for upcoming projects as well, in collaboration with them to develop kind of this plasma brake that is really able to be scaled for the scale of almost all small sats launched.
Okay, well, it's I believe now we have a better understanding of what Aurora propulsion is and what you do, and maybe even interest for customers. I see there are, the next would be in my list of all the companies here would be North Base, and there Tommi Rasila. Do we have Tommi here?
Yes, Tommi is here.
Okay, do you have video feed or?
Yeah, just a sec. I just need to leave the breakout room now.
Okay.
Yeah, because we have that too. Let's see if my video works at the moment. No. My video doesn't start. Let's see. But you can hear me anyway.
Yes,
right?
We can hear you perfectly.
Yeah, good. Yeah, for some reason my camera does not open. But anyway, let's just forget about that then.
Yeah, so we can hear you. That's all we need. So North Base, what's North Base?
Well, we are a startup founded in 2019, based on the notion that we figured that because there's so much new space activity going on and new satellites being launched all the time, then eventually those satellites will need ground station capacity as well. And being in Finland, we know that our ground station capabilities are very, very small and scarce between, few and far between. And now we do know that this is very good place for ground stations. We are very close to, or relatively close to North Pole. And really, when you think about, if you check the globe, I do like these old-fashioned, globe maps, which you can hold in your hand, and you can check that the other regions which are as far north as we are, that's like Sweden, Norway, Alaska, upper parts of Canada, Russia. So in that comparison, I would say that Finland is very good space for ground station operations.
Yes.
So that's what we're up to, and that's why we're here today.
Okay, so you offer ground station support for satellites. Okay.
Yeah, definitely.
Okay, and the northern latitudes of Finland are for polar orbits. That is so. I believe a station in Finland can catch almost every second orbit of a polar orbit satellite or something.
Yes, or even better. So definitely now we're building our first ground station now, and this will be in Tampere region. This is where we founders where we're based. So that's pretty natural, and that will be a UHF VHF station. So for instance, for LEOP needs, if you need to put your satellite on orbit, please be in touch with us. We should go live next month, so it's pretty soon, and we can support your LEOP phase from there. But then for bigger data download needs, for real payload, that will be our Muonio station, which will open, first quarter next year. In there, we will have a 4-meter Cassegrain antenna, and we will have S-band up and down and X-band down. And we can go to Ka and Ku, and we will have UHF and VHF in there as well. But that will be 68 degrees northern latitude.
Okay. Are you the only ground station company in Finland?
More or less, yes. There's some very small, more like non-commercial antennas around there.
I believe Aalto-yliopisto has one for its own use, but that's not the commercial.
Yeah. And also I know that Reactor has or is building something, but those are like or more like publicly funded and stuff. And anyway, Reactor will be here soon, so we can ask. But the FMI facility in Sodankylä, the Finnish Meteorological Institute facility in Sodankylä, is the only place where they have like real antennas for this use in Finland at the moment. And when I compare that to the 100 plus antennas the Norwegians and Swedes have, so that really brings up the Finnish SISU spirit that we need to do something for that, because we have lots to offer. Finland is a very good place. We have lots of room in Lapland, and we're one of the most transparent and non-corrupted countries in the world. So I do think that we will be able to succeed in this competition.
I believe so. So what are you up to next with your company?
Well, of course, this Tampere station we will complete now and then continue the Muonio station. But I'd say that maybe there's two things. First of all, we have a long-term vision that we will have a real space station in Lavivaara, which is a curious place. If you come to, we just had a presentation in our breakout room. It's an abandoned hotel and ski slopes and everything. It's exactly from the movie Shining. So we will be able to bring lots of capacity in there.
That's very north, isn't it?
Excuse me?
Very north, isn't it?
Yeah, 68.5 degrees north. So it's north from Sodankylä, it's north from Kiruna. So
that's Utsjoki style north.
Yeah, almost there. It's 10 kilometers north from Karesuvanto, Lavivaara.
Okay.
Lavi Vaara. And there's nothing in there, but also the ASCAT constellation antenna is being built there.
Okay.
Right now.
And soon there will be a space station or a space ground station.
So just follow, stay tuned, and whatever you want to do in there, please be in touch. And what I can tell you is that this week last week we have signed an MOU with an Indian company about LEO phase of a couple of satellites. So stay tuned for those news as well. It's not yet public, so we can't publish that. But there's things happening in Finland on ground station segment as well.
Okay.
So stay tuned, and for all your needs, please be in touch.
Yes, I'm sure we get a good picture of what you are. Thank you. Next in my list, which I have to hurry a bit now, is Hult and Matti Anttila. Hi.
Hi, thank you, Markus.
I believe your company is a little bit better known between startups and the Airbus level.
Well, who wouldn't be a startup? Because we are we are still, or what's the limit between startup and an experience company? But yes, Huld is actually like relatively new name among the space companies list. However, it's a new name only, or new brand. So we started as a Space Systems Finland in 1989 already. And then we started basically with software and systems engineering. And so far we have been involved in more than 160 ESA missions, mostly onboard software, ground processing software, and systems engineering. But about 2 years ago, when Space Systems Finland was merged with another Finnish engineering company, we actually acquired a bit more talent here. And now we are actually quite much into mechanics as well. And that's basically what we are now trying to say here in this space workshop. So stay tuned today at 16:30. We have Kevin Vainio and Jaakko Kaartinen presenting our Visa Woodsat participation. So basically the question is that what can an experienced space company as Huld or ex-Space Systems Finland do for new space companies? Is that actually quite much? So we are like harvesting the experience that we have gained in these bigger missions to these new missions now. And in fact, currently Jaakko Kaartinen is in Huld's breakout room, and you can tune there after this my presentation as well.
Okay, nice. So what are you offering to the markets of new space, as you mentioned?
We are actually offering services. So we are offering like software just that we do for ESA or EUMETSAT as well, or EU. And then we are offering test services, and that's what we have been doing actually for a couple of years, even when we were in Space Systems Finland and currently at Huld. So test services for software and systems. But now we are offering also mechanics. And by mechanics, I mean the classical mechanical design and mechanics, but also this additive manufacturing. And that's actually quite neat because we can dramatically reduce the price and the mass of the systems by additive manufactured mechanics.
So do you have, so to be clear, you have your own capability of additively manufacturing space grade stuff?
We have our own capability to design it and then to outsource the actual the production of the mechanical.
Like the printing process.
Yes.
Okay. What kind of how is it different when compared to designing in the traditional way, space grade, let's say, metal parts?
It's actually quite fast because you can make fast prototyping, and then you can make fast testing, and then you can make fast implementation. And fast means in space business also cheaper, because usually the expense comes from the labor time. So that's faster. Yes.
Yeah. That's quite interesting because I think people who follow these kinds of circles in this industry know that additive manufacturing has been used to produce like rocket engines even.
True. Yes.
So it has even found use in like structural parts. I believe we are speaking of additive manufacturing of metal, so like 3D printing.
Yes. And like today, 1630 was 1630. We have this one session by Kevin Vainio about Visa Woodsat, which is this first Woodsat and the selfie stick mechanism. So it's not a joke; it's a selfie stick, but it's an extendable selfie stick. So it's like a camera boom, and that's something that we are really looking forward, because that could be then like productized for different kind of sensors to make the sensors be a bit more like distant from the spacecraft as well.
Obviously, magnetic sensors require.
Exactly. Yes. True.
Yes. Okay, that's very interesting, because I believe many knew what Space Systems Finland was, but now you've acquired this mechanical skill set and capabilities. That's very interesting. I believe Huld will be a great player in this field in the future.
Yes, I think so too.
Yeah. Okay. Thank you for participating.
Thank you, and stay tuned in Hul's breakout room as well.
Yeah, that
Okay.
would be interesting for sure.
Great.
ISAI would be the next in my schedule. Is Tero Vauraste here?
Yes, here we are, Markus. Good afternoon,
Yes.
everyone.
Good afternoon. So ISAI, you are one of the newest space companies in Finland, a very kind of known one.
That's right.
What are the services you provide? Just to clarify.
ISAI's story began in 2012 with the 3 Finnish students from Aalto University, and the company has evolved since magnificently to become like, oh, that sound of music is not from ISAI. I don't know where that's from.
It's from there. I'll mute it. Okay, continue, please.
So, the story is making great success. We have been able to welcome new customers from all continents within the past couple of months. And what we provide is that we provide SAR, meaning synthetic aperture radar data, which enables our customers to have a great overview of basically any part of the world, any time of the day, in any weather, with the help of our microsar satellites. And up to date, we have launched 14 satellites, which are up there serving our customers, and there is more to come within the next couple of months. So we're expecting the constellation to grow rapidly. We have secured funding of $152 million up to date, including national and international investors. And in addition to that, of course, we provide solutions where we have focused ourselves within the past year or so for natural disasters, especially for flooding solutions. And obviously, we are also ready to discuss selling a satellite or a number of satellites for our customers. But the main area of service for the moment is microsar satellite data and images from, say, 5 times 5 kilometers up to 100 times 100 kilometers with different resolutions, any time of day, any weather, where SAR data has this great opportunity of moving forward despite of the weather conditions, despite of any optical problems which may have arisen.
Okay, that's interesting. You have a new service called Coherent Ground Track Repeat.
That's right.
I know this much about your company. Could you tell me a bit about this?
Yeah, sure. So because the constellation size is growing, we have now been able to appoint a small number of the constellation to a so-called Coherent Ground Track Repeat. So what does it basically mean? So the current constellation works the way that the satellites go around the globe on polar orbits, and like the Earth rotates underneath. So that means that each of the satellite looks into different places at a different time of day. However, with this Coherent Ground Track Repeat, one satellite looks into accurately same spot of the Earth each 24 hours. So that means that, for instance, if you need to have a comparison of your area of interest with this 24 hours, so you take 2 images, and with these 2 images, you can track changes with different types of technologies, including interferometry, where, for instance, we have looked into the Icelandic volcano eruption, which has taken place 2 months ago, where we did great interferometry stuff out of that. So with the interferometric approach, you can really detect small changes which have taken place in one particular spot. And with the current constellation situation, we can cover like 2/3 of the globe with this service. And as there are more satellites to come, we will be able to come up with the 90 or 100% coverage within the next couple of months.
Okay, that's impressive. Clearly, you have quite wide coverage already.
Oh, indeed, yeah. And as said, we grow internationally and are happy to serve the international customers on all continents, which has been the case for the past couple of months. So good growth.
Okay, so you've your constellation has grown very rapidly. So how can if I want to access ICEYE services, how do I do that?
Yeah, that's an important question, of course. So we welcome everybody to use our services through our website, www.iceye.com, where you can first of all have an access to our archive. So the archive images are available to a certain extent. So there are more than 18,000 images available already. As a research organization, you can also access our data through ESA programs, for instance, with the TPM, the third-party mission. And we're also expected to re-enter the CCM, the Copernicus contributing mission, where with certain conditions, when they apply, you're able to access our data for your area of interest when you make your request through the European Space Agency. With a commercial approach, you're welcome to visit our website or contact anyone within our sales, and we'd be happy to have a look into your wishes and thoughts, provide you with a feasibility study with your areas, and see how the satellites will bypass, give you exact pricing, and have a look into what your needs are, and then appoint a suitable image category for you. And we're also expecting that within the next couple of months, the system will be even easier, so you can make your request directly through a so-called tasking API, where all the services will be available through the website, and you can say that this is the date, and this is the time, and this is the place where I want images, and you get your request in, and you will get the response through the web inquiry through a tasking API application.
Okay, that's a very thorough answer to a question.
Thanks. Yeah.
Okay, I believe we now know what ICEYE is up to, and thank you for participating.
Thank you very much, Markus, and welcome everybody to have a look into ICEYE services.
Yeah, sure. Next is Yuxlon International and Miguel Angel Ruiz Souza.
It's me. Hi, Markus.
I don't think I pronounced any of those correctly.
Oh, I understand both of them, so don't worry about it.
Okay, so Yuxlon International, is that how you say it?
Exactly.
Okay, nice. You do X-ray stuff, that much I know.
Exactly.
Okay. So how are you a space company?
Okay, we see our X-ray technologies can help to all these satellite companies, the manufacturer of the satellites, just for improving the quality. Just images like when you go to the doctor, you use X-rays just to see if your parts are okay or not. We see us a little bit under the non-destructive testing, but also now with the new comment capabilities with the computers and so on, we have the biggest business policy now with computer tomography. So we can expand our business also in the metrology area.
Okay.
Like a coordinate machine. So you can use X-rays. For example, in additive manufacturing, you can look for quality control, the quality of the powder. If you have in all these rockets a lot of cooling channels, if they are free of the powder or not. And you can use also the X-rays, like to see if the parts are inside the tolerance. So we believe you can use us in the quality production process, but also in the research and development areas. Because of course, additive manufacturing, especially in this area, we are speaking about relatively small series, but you can speed up with computer tomography all this process.
So computer tomography is a quality assurance tool, and it's a very, very unique sort of tool for that.
Yeah.
Are there any, like there are many ways of imaging materials? Why is X-rays the good choice?
Yes.
Why does X-ray make sense?
Yes, for example, this area for us is very amazing because even internally, it is a mixture of all areas. We are really strong in electronics, and of course, in all these satellites, you had a lot of sensorics and PCBs, electronics parts inside. So you need to have a very high amazing resolution, or you can go to the solar cells. So there is a lot of different applications, also the propulsions, or the small motors, electrical parts. So we see really for us like a new space. Let me say for us it was the COVID opening our eyes for this new sector, and it is amazing to see how flexible it is, how quick it's growing, how many different the amount of startups around the world is really amazing.
Yep. What are you in Scandinavia? What are your plans here?
Yes, that is one of our topics we are also looking. So there is someone in the auditorium who could have interest in taking the representation of our products in that area. Will be very welcome, because that was in the past not the typical aerospace area for us, and that is something that we are discovering right now.
Mm-hmm.
So we are open for partnerships, and also we are looking for companies who would like to send us samples, parts, and then we could do these services, these applications free of charge, if we are willing to do something like a marketing to creation material. So because that is for us definitive a new activity area, this new space.
Interesting. So I get it. Yxlon International has a lot to offer to space industries.
Yes.
Okay. Thank you for participating this talk. Okay. Next in my line would be Reaktor Space Lab and Janne Kuhno. Okay. Hi.
Yo. Hi.
We can see and hear you.
Good.
So Reaktor Space Lab. What are you doing?
That's a good question. We've been doing silently stuff for a while. We've been working. We are a company that was established in cooperation between Aalto University and Reaktor, software company Reaktor originally, and we have been since we made together with Reaktor our first satellite, Reaktor Hello World, which is in orbit, and now for the past 3 years or so, we've been working on 2 European Space Agency missions called WCube and Sunstorm. And these missions both actually launched during this summer, which is quite rare that these projects were started a long time ago in different time slots, but due to COVID, they ended up being launched roughly at the same time. So we've been really busy during this summer operating 2 new satellites. And we are in the middle of LEOP for both of them. Both their platforms have been commissioned, and we have established attitude control and communications from our ground station here. And we are now underway commissioning both the payloads, both on WCube and Sunstorm.
Okay, so you have, so you are up to a lot, it seems.
Yes.
Okay. Your Hello World was launched in 2008. Your satellite, Reaktor Hello World.
Yeah.
2018. So has it been responding? Is it alive?
Yeah, we are approaching. This week we will reach 1,000 days in orbit for Hello World, and we have had for the entirety of the period we have had link with it, and we are still operating it, albeit on a fairly reduced schedule because the 2 new satellites have taken all the attention recently, but still Hello World is alive and kicking, and especially its hyperspectral camera made by VTT is still working and producing amazing scientific results, or at least potential for scientific results.
Okay. As a first spacecraft, the feat of launching it and not breaking it in 2 years is achievement in itself.
Yes, definitely. And Hello World was made in cooperation with Reaktor in a way of an agile software development way, and no space approach to software was made in there except for the usual stuff that you do. So this is really a standpoint that you can actually make the software running on a basis like that as well.
Yeah. So what next?
Up next, Hello World has proven in its operations and datasets an important starting point for our company, and we would like to expand on that basis. and we are working on, let's call it Hello World version 2, which won't be only a satellite, but something else. And we are underway of radically realigning our company according to this. And you may expect, we are a bit hush-hush about it right now, but you may expect towards the end of September, you can expect big news from us in that respect.
Okay, so we will hear more from you then.
Correct.
Okay.
Yes.
Thank you too for participating.
Yes, thank you, Markus.
Okay, next I would have Nanovac AB and Thomas Engstelt.
Yes, hello. How are you?
I'm good. Well, yes, and there you are. Nice, and we have video and audio working. So Nanovac, you are producing vacuum chambers. Is that correct?
Yes, that's correct. So Nanovac is focused on building thermal vacuum test chambers. And we build solutions for testing components. We also build chambers for propulsion test applications. And also in general, all kinds of vacuum systems that could be used in the space industry. So it's not necessarily always a thermal vacuum chamber, but it could also be a general vacuum for storage or for other types of applications to confirm operation of a component. Okay. So yeah, that's what we do. And that's basically the core of our business is vacuum and the vacuum technology of space.
Okay, so out of all vacuum chamber manufacturers, what are the benefits for me for choosing Nanovac?
I believe the strength that we bring to the table is that we basically build all of our systems to customer specifications or requirements. So we do have a range of custom or standard components, but they're always customized to meet the specific requirements. So that would be in terms of the temperature range, and also the type of ports or other analytical equipment that you would put on the chamber. We also do thermal quartz microbalance measurements, residual gas analysis work inside the chambers. And what we offer these days also to potential customers is that we have a test chamber at our facility in Sweden where you can conduct tests while waiting for your own chamber. So we're providing sort of a bridging support, provided that we can meet the temperature requirements on our in-house chamber. But I think the flexibility and the adaptability of our company to meet customer requirements, that's really our strength and the benefit that we bring.
Okay, that's almost any space project at some point requires like vacuum chamber services.
Correctly, and I think that's the interesting aspect, because our ambitions were fairly small once we set up building chambers, but we've seen that the overall demand has skyrocketed, and I think that comes along with the increased demand for CubeSats and smaller sats, and the increased launch schedule. I mean, there's stuff going up in space quite regularly these days.
Like almost every week now.
Yeah, there's always something going on. So in some shape or form, as you know, everything has to be tested. And so we are happy to provide and help with that solution for anyone working with space.
Okay. That's nice and concise.
Yes, quick and easy. I thought we were kind of running out of time, so.
Well, yeah, but
perfect.
Yeah, but we can make a bit more time. So thank you for you too for participating.
And thanks for having us.
Yes. Reorbit would be next.
Hello.
And he'll set to
Markus.
Hi. So you can take your time. So even though we are like 5 or 4 minutes over.
Yes, I'll try to keep concise and still give the message.
Okay. So you are from Reorbit. So what does Reorbit do?
Yes, so Reorbit is an early stage startup, which is almost 1.5 years old now, based in the capital city of Finland, Helsinki. So just before I go into what we do, I'll just give a brief background of why we do what we do. So basically, if you look at like satellites as such, So the focus in all the satellites that have been built since, say, Apollo program all the way till now is that people try to push quite a lot of functionality into one metallic piece of box and then try to just launch it and keep your fingers crossed that these things would magically work perfectly fine. But now, given that, as the previous speaker told, there have been launches every week now, and that's going to get more and more. And also, there have been quite a lot of exotic applications that are just coming up, like going to moon again, manufacturing in orbit, mining asteroids, and so on and so forth. So all these kinds of new applications are coming up. So with these kind of excessive growth of satellites, with these kind of exotic applications coming up, you can no more build satellites like what you can build, which is where you put everything on Earth, put all the functionalities and launch it. Whether you have to start, dicing up your satellites into smaller pieces and give the satellites ability to talk with each other and reconfigure the satellites in orbit. So that's precisely what Reorbit is doing. So Reorbit is building technologies that would enable satellites to connect with each other in space, to talk with each other in space, and become very autonomous in space.
Okay, that's a bold mission for a company. I think that sounds quite complicated. You have this advanced Gluon microsatellite platform that you have mentioned. Can you tell us about it?
Yes. So as a stepping stone towards, as you say, yeah, it's quite a complicated or I would say like bold vision, I would say. But in order to sort of make it less complicated, what we sort of are doing is like we're actually entering the market providing a microsatellite platform, the Gluon platform, where the focus is one on designing this platform for beyond LEO orbits, where it's intended to operate in GEO, MEO, and deep space missions. So the focus has been put on very high reliability, but also this platform comes with some of the advanced features that I said. So the Gluon platform has autonomous station keeping and autonomous FTIR. So you could straight away start reducing your say operations costs to a great extent. And then Gluon also comes in with a very modular, advanced design where I think there was a talk from Airbus on the FlexSat. So we are sort of following a similar approach with the Gluon platform, where there is ability to change your advance your platform as your payload advances with very less recurring engineering. And on top of it, Gluon also has some of the elements to enable reconfigurability in orbit. So we are taking a small step towards a bolder vision with the Gluon platform. And the platform is reconfigurable or flexible from say 100 kilogram all the way to 500 kilogram in the wet mass. So that's the range that the platform would. Yeah.
Okay. And so autonomy and reconfigurability are important features for this kind of platform.
Yes, exactly. As I said, so that's like the in the center of what we do. So Gluon comes, as I said, with quite advanced features with the autonomy on the station keeping and FTIR, but also some features on the reconfigurability. So what we say with Gluon is fly and forget if you're having a constellation. So you launch your first satellite, then you launch your second satellite. So in a way, these two satellites can talk with each other, and then what you could say is like, okay, you have three satellites in a constellation, and you want to keep them like 120-degree apart. You could just say, okay, keep this 120-degree apart. So in a way, the platform would take care itself to align this. So we call this fly and forget configuration. So
fly and forget.
Yes,
that's a catchy term. So like, what's the next step for your company?
So next is also, we've actually had a talk in this session previously. So we are also actually working on a demo mission called UCO mission, where we'll be showing this advanced distributed flying in orbit, where we will have two small CubeSats that will be launched independent of each other, where you have two different payloads on this. So once they're launched in orbit, we will then rendezvous proximity, connect this wirelessly with each other, and then we will exhibit certain different missions where we assume one of the platform is not working fully, where the other is working fully. Then we start sharing data between these platforms. Also, we will showcase a multi-static approach with these two platforms, where you will have two different payloads, and we want to make sure that these payloads operate as, or the data that you get from these two different payloads are in a way integrated and sent to the ground as one. And also we would test case that if you want to have the ambitions of flying in a distributed architecture, the ground segment should not see these two platforms as two different individual platforms, but they have to see as one single platform. So that's also a test case that we would do. So that's our next step. It is quite, again, a bolder step, but we are advancing there quite fast, and we are planning to have this demo mission on the UCO Q4 2020 to Q1 2023. So that's
okay. So in that kind of time scale, we can see demo missions for that.
Yes.
That will be interesting. Okay. Thank you for you too for participating. And next thing I believe is the plenary session on 14-15. And I think the companies can be reached in their rooms.
So, welcome back everybody. Nice to have you all online. And Markus, thank you very much for this session. Although we had slight technical problems, but nevertheless, the interviews were very, very interesting. And the companies are really starting to provide a really interesting products which are taking the academic world further as well. So thank you, Markus. I will also remove you from spotlight, and let's try to get forward with our program. Next in the program, we have a plenary session, and as it was told before, we had one cancellation of very last minute. Vytenis unfortunately had to announce that due to medical reasons, he is not able to give a talk today in a agreed slot. So it was a very tight schedule to find something interesting for both Earth observation community and space community. And I'm very glad that Andris Slavinskis from Tartu University helped us out, and he's going to give a talk about Space Imaging Simulator for Proximity Operations, SISPO. And it's a remarkable system which can develop images of faraway asteroid objects. It's sort of rhymes with a digital twin topic from very morning session where Matti Möttus was telling about digitalization of the entire scene. So here you can see how the digital twins of asteroids are coming about. This is also a very excellent introduction to the long session tomorrow. We have 3 sessions called Onboard Imaging, and these are basically a planetary imaging sessions, asteroid imaging and asteroid missions and planetary missions with very high profile talks and very high profile presentations. The second presentation today in our plenary session is health issues in connection to spaceflight. And this is an introduction to also a small interview what we're going to have today after the session here. And here Kari Luojus from FMI is talking with Maija Lönnqvist and a couple of other people about the topic, should Finland have an astronaut, and what should be done in order to have an astronaut in such a small country as Finland. And this talk, Health Issues in Connection to Spaceflight, is given by Brigitta Ganse from Germany. And she's a medical doctor and doctor of science who has been working with health issues of astronauts for a long time, and I'm expecting very, very interesting talk. So Brigitta, are you already online?
Yes, I'm here. Hello.
Excellent, excellent to have you. Just checking that we have all the important people for the plenary sessions already online, and we can go forward with our program. Andris, by the way, are you also online?
Yes, hello. I am.
Excellent. That's
fine-tuning the slides.
So, any other topics, issues, questions about the program today? I would also very briefly tell you what is happening after plenary session. So after plenary session, as I said, we have a small interview with Maija and Kari, and then we have evening sessions. So if we take the whole day program here, we having at 3 o'clock Earth observation for society goes forward. We have another block of CubeSat missions, and then we have a session on GNSS, geolocation, navigation, satellite services. And after that, 4:30, we start with interactive sessions, and interactive session is arranged in a way where every single presenter in interactive session will get his or her own interactive breakout room, and is able to give a presentation or discussion on the topic of the interactive session during 20 minutes. After 20 minutes, we will switch the new presenters to the same rooms, and then we will have another 20 minutes for the next presentations there. So you can already now go to the test rooms and see that your presentation is working. So there is a testing room available. We have been already creating also a questions for speakers room. So if you feel that your questions were not answered, or the speaker feels that she or he would like to talk more with a couple of people about these topics, then the questions for speakers room is empty and can be used anytime for discussion online. Any questions about the program and the arrangements so far? If not, then I would already ask Andris to put the first slide on so we can start the session, check out all the technical problems, and be prepared for the plenary session, which is coming next.
Yep. Hello. Thanks, Jan, for reacting so quickly. Right. I hope you can see my screen now. Huh?
Excellent. We can see your screen very well, and we can hear you also loud and clear. So technically, from the technical point of view, everything is all right. So we have still 1 minute to go. Andris, are you giving this presentation from Tartu?
No, I'm in Riga.
Yeah, you are from Riga. Excellent. So it's starting to be really online world where we are, from the line quality, cannot tell anymore who is attending from where, and we are getting rather nice video bridge and sound bridge to everywhere in the world. But thank you very much, Andris, also for reacting so fast, and I will hand my floor over to Tartu team, and Andris will talk about CISPO system. So Andris, be my guest and start your show.
Yeah, thanks a lot, Jan, for giving this opportunity to present for a much wider audience than we expected. So first of all, I was very excited about this conference. We bought tickets quite in advance, and then there was a bit of a problem getting reimbursed for a conference that you don't attend, but thus far it has been very nice online. So thanks, Jan, and the rest of the organizers. So this talk, I think, is very suitable for a Finnish satellite workshop because it covers regional topics, and really this is something which you can join. So this project is something you can join from anywhere in the world and start using it, start developing, or do whatever you want. We try to run it as an open source project and try to improve the functionality all the time. And so how it has happened thus far was that so my friend and colleague Mikkel Pajusalu developed initial version of this tool. Basically, he realized that the best way to render something, including space scenes, is by using Blender, an open source tool, which runs a nice cycles rendering engine. So he created a system that only he could use. And then I moved to, I went from the US straight to Finland, to Aalto. And there, Gabriel was keen to start his master's thesis on this topic. And he basically implemented the system in a way that we can use it now. So basically, he made a GitHub repository, and that's something we use since. And then, of course, everyone else here in the slide have contributed. And I'm pretty sure next time we'll be giving this talk, there will be Luleå University of Technology logo here, because currently the most active students are thesis students from Luleå, and yeah, contributing a lot, but just haven't yet produced results to present here. And we also have a pupil joining from Latvia. So really, yeah, easy to join this project. I'll start with 2 boring slides. So this is an imaging simulator. I'll show a lot of nice images, but I'll start with a bit more boring stuff just to explain what SISPO is. So it's a photorealistic, physically based rendering engine, rendering system that uses Blender and cycles. So maybe there's a mistake, physics and physically, there's a slight difference. I don't know that well myself. So, but what it can do is automatic surface generation with procedural displacement, textures, and micro polygon displacement, allowing for arbitrary level of detail. We can also model gas and dust environment. I'll show some nice pictures there as well. It includes several camera models that help to simulate realistic optics. And then Olli has contributed with an open GL rendering engine, Olli Knutila from Aalto University. And it's all done in Python. So with respect to Blender, Python can be used within the Blender as a scripting language. And it can also, so Blender itself can be scripted from outside, so without any user interface. And that there we also use Python. Then one of the first cases to test the system, the whole pipeline, was 3D reconstruction, how it was used. And one of the recent developments is that we are developing an attitude dynamics module. So this work has been started already. So it doesn't. I haven't updated the slides properly, and it's used in the OPIC project, Comet Interceptor OPIC project, which since we have an empty slot tomorrow, I might present OPIC in that slot. We have to agree with Jan. And it can provide all kinds of data, the tool. So now the program flow, this is, I think, thanks to, so this kind of system was produced by Gabriel, and if he would be around, he could tell more. But anyway, we can define the inputs of the system. So where we want to be, what we want to model, and what kind of details do we want to see. There's a model that propagates the spacecraft and the objects that we want to see, so orbital propagation. And then there's a more complex structure of how rendering happens. So we can render stars, so the background separately from our foreground object, and then compose that. Then there are compression steps and reconstruct steps as part of the normal pipeline. But then going to something more interesting, how more complex structures are made, or how more complex renderings are made. What we use is basically, as in any kind of complex system, we take simpler parts, add them together, and then get the final rendering, as you can see here, where we combine craters, rocks, and sand in order to gain an image like this, where you can also perceive the depth of it. I mentioned gas and dust. So this is done by this is done by Timo Väisänen. A couple of years ago, so currently there's a new gas and dust model being developed specifically for Comet Interceptor, but at the time we didn't have such an option. So Timo took another option and did a really great job. I would say that these renderings are, you can't say if it's real or not, except that you maybe know the comet itself better, but they look properly real. Another render made with gas and dust. So yeah, so as I said, Comet Interceptor OPIC is one of our use cases. Therefore, the getting cometry activity, implementing cometry activity is one of the main goals currently. Okay, so going further with a few examples how this is used, we can look at an image of Itakova taken by Hayabusa mission, and then compare it with two options. One is based on OpenGL, which is also part of CISPO, and renders much more faster than Blender on Cycles. And then we have the Cycles rendering, where basically there's an option to add more and more detail as we wish and as we zoom in. So it's not just for representing objects as we see them imaged, but we can also create new details and new, basically new detail. Yeah. And this is what Mikael tries to show here, that we can take the same image as from before and zoom in and still get more and more detail there, and nicely modeled shadows and everything. So at that time when this was done, he got to approximately 5 centimeters a pixel, but then he ran out of time to go more detailed. Another example is modeling of the lunar surface. This is thanks to the interest comes thanks to a project in Tartu for basically a feasibility study for a lunar rover development. And this is so 3 images are compared here, and the last one is the actual image taken by the Apollo 15 mission. And then in the middle you can see like a full-fledged rendering with details and rocks and so on. And to make it even more fun, Mikael made a nice video which shows how a rover would be driving around the moon. And basically, as the nice thing about here is, as the rover drives, it can create more and more detail. And of course, what we see in the background is less detailed because we simply don't see it. Another fun application is modeling of a cave. Actually comes from an online tutorial, then a line for a more space application. You can imagine this maybe as a lava cave or something. Then I also mentioned 3D, not 3D modeling, but 3D reconstruction. And here's an example where basically Jaroslav took a 3D, basically he took a series of renders of 67p and then performed fake flybys, and from those images reconstructed the object. And here you can see the result. One of the last slides about OPIC. This is also made with CISPO and Blender, and just one of the first videos on OPIC, what we would expect from the mission. This is a fairly slow flyby. And then last but not least, I've asked Mario Palos to make a CISPO demonstration video for the space travel blog. And here's the result. It's not necessarily scientific, but a lot of the models and images you see that are the kind of basic models and images you see are coming from scientific data, but it's made more as a tool of as a way to demonstrate the tool. I think this is one of the nicest seeds. And yeah, what is missing here is the actual, if it's done like at the end of the render, the final render would have like the lights and shadows properly. So the Jupiter in the previous scene would light up a bit when the spacecraft enters the atmosphere. But yeah, these are the final scenes. Thanks a lot, Jan, for giving this opportunity. And we can, I think, move on. I can't hear you, sorry. Can others hear Jan?
No, he seems muted.
Okay, yeah, no. Okay, I heard someone else, but not Jan.
So welcome back. Yeah, for me as well. So sorry, I was muted. Thank you very much, Andris. Do we have any questions about this wonderful simulator? And maybe I will give the first question. So, what kind of tools you have on the background? Is it a really expensive proprietary tool chain to generating pictures?
No. This is all Blender cycles. All basically, you can get it online. You can even get it from GitHub. So compile it yourself from binaries.
So the beauty of this system is that it is freely available, free of charge for entire research community, isn't it?
Yes. The only problem that with the SISPO is that it's not really made like user friendly.
So why do you need this kind of system?
The examples that okay, sorry, this is a bit awkward. Okay, the examples that I showed would be the primary applications. But yeah, I'm really having a hard time to talk because I'm hearing feedback all the time from you.
Okay, I'm trying to adjust my system before the next talk. But all right, thank you very much, Andris. Do we have one short question somewhere else as well? If no, then I would ask Birgitta to come online and share the slides.
Hello, yes, I will. The window was in the way. So hello, everybody. Can I just go ahead? I will just go ahead. So hello, everyone, and thanks for having me. Thanks for listening to my talk about a totally different topic, actually. So I will give an introduction on health issues in connection to spaceflight. And this is a huge field. This is a broad field, and I'm giving a whole semester-long lecture series at the university about it. So I can only cover it very roughly and very superficially. And if you have more in-depth questions or more details that you want to know about, you can come back to me later. And I will still stick around for a while in the outbreak room or breakout room for questions to speakers. Actually, we have a really, really interesting phase in the history of spaceflight, of manned or human spaceflight. We have long-term missions planned to Mars and beyond that come with extra medical issues and health issues. And we have space tourists going up to space in a larger amount now, who are the first people with diseases or who are not perfectly healthy. And that's a super exciting topic, I think, but it's also extremely relevant because I'm sure that things will turn out to happen. And it's amazing to observe what's happening and what's not happening. And today I will just give you this brief introduction, but if you want to know more, there's also more resources you can look at. So who am I? I'm a university professor for innovative implant development, actually. So I'm not a university professor for space medicine because those positions are very rare, but innovative implant development is very closely related to what I research. And they also let me do my space research, which is amazing. And I'm an orthopedic surgeon and a physiologist by training. and I teach space medicine at the university. And I used to work at the Center for Space Medicine in Berlin. And afterwards, I was head medical doctor at the German Space Agency, DLR, in Cologne, Germany. So I have had quite a long experience in space medicine, and then went into university to be able to decide myself what I do, and to be able to steer the topics that I do research on, or that we do research on myself. Because when you work in a space agency, they usually have people who decide the topics that need to be researched, and then you can't really play around as much as you like. And that's what I like about being a PI from the university side of things. And the research I do is mainly in bed rest studies. I will come back to that later, what that is, and explain it to you, and on the ISS as well. So what is space medicine? Let's hop into the topic. So it's the research or the discipline that deals with medical and health aspects of the human body in spaceflight. And the research community deals with one, basic research, physiology and weightlessness and confinement. Second, health, disease and medicine of and for spacefarers. And third, development of countermeasures to counteract the immobilization effects of weightlessness, which is a really important issue. And those countermeasures are currently either exercise countermeasures such as treadmill, bicycle, or resistive exercise training, or nutritional countermeasures, medications. What we're currently testing is human centrifugation to spin people to generate artificial gravity. Or currently we're also in the ISS experiment that I'm involved with, we test electrostimulation of the muscles as a countermeasure. What is different from Earth? So in space flight, we have weightlessness. So we have weightlessness when we're in Earth's orbit, but we don't always have weightlessness. Sometimes we have hyper-G at launch and landing, or when we speed up on the way to Mars, for example, there might be periods with some gravity. That's why we usually talk about microgravity in the field. Then we have radiation, and radiation is a really big and heavy issue at the moment. And the big space agencies are planning to do major research on radiation on the Gateway space station, just because the low Earth orbit, so when you're in the orbit of Earth, that is still protected by the Earth's magnetic field, and there is no proper space radiation there. And since the last people who left low Earth orbit were on the Apollo missions in the early 70s, it's been a very long time, and there's almost no experience with radiation exposure of humans. So that needs to be done in the coming up years. Research that more and have a look at countermeasures or protection. And then isolation, confinement, and a very tight schedule are major issues, especially on the psychosocial side. For example, psychological problems, depressions, or also problems among the crew. And it's a very important issue to make sure that these issues go very well. And that's a big branch of space medicine at the moment for people to find solutions there. And then we have limited resources, foods, drinks, and medicines. It's not that relevant on the ISS because supplies regularly arrive. But when you go to Mars and the medicines are empty for whatever reason, because somebody has used them all up, then there's nothing else left, and you can't treat someone anymore. Or once your favorite food is gone, you can't make new food. Then it's just gone, and you can't have more pizza or whatever it was. And then there are gases, toxins, and smells in the artificial environment that are potentially dangerous and are real threats to life. It's not only theoretical, but it's a real actual threat. And we've got constant noise that is a very massive stressor, and among other stressors such as smells and etc. So these are issues that are really different. And this is a slide that explains the longer term adaptations of the human body to weightlessness. So this is stuff that does not occur when a tourist goes up for a few hours or for a day, but this stuff happens when you're there for a bit longer. And we've got bone and muscle wasting, we've got space adaptation back pain because the spinal cord or the intervertebral discs, they stretch out and the body just becomes longer on average by 5.5 centimeters. But it's not a cure for people who are too small. When you come back, you grow back to normal again. So you shrink back to the normal size. And then kidney stones are a big issue because when bone is resorbed the calcium is secreted over the kidneys, and then kidney stones can form, and they can cause very severe pain, but also infections. And that has already led to some missions to be stopped, or people to fly back earlier than planned in the past. That's a really serious issue that has been a topic all the time in spaceflight. Then there are changes in muscle tissue, and there's a fluid shift in weightlessness up to the head and upper body, and astronauts get a puffy face and bird legs, and that comes along with a lot of cardiovascular issues. There's a decrease in blood pressure that is also not permanent, so when you come back to Earth, it's gone. And orthostatic intolerance, that means that people faint when they come back to Earth, and the blood is collected in the legs and not available for the brain anymore. Then there's impaired vision. That is actually something that has been overlooked for many years, for several decades in space medicine, and has only been kind of discovered maybe 10 years ago. And that is currently a very hot topic, because those changes are permanent and countermeasures are desperately needed. And then it's a fact that the heart shrinks, because the heart muscle is not used as much in weightlessness. It doesn't have to pump as much as on Earth, because it doesn't have to counteract gravity. And so the heart shrinks. And once you land on Mars with a smaller heart, it's not able to pump as much as on Earth, and it has to spend some time growing back, like a week or so. It's not very long, but for the first days after landing, it's an issue. This is a list of the medical problems most encountered in spaceflight. It's taken from the book mentioned on the right bottom side. And the most important issues are anorexia, so that means a loss of appetite, space motion sickness, fatigue, insomnia, dehydration, dermatitis, back pain, upper respiratory tract infections, so eye irritations, then bleedings under the fingernails from the EVAs, from the spacewalks, urinary tract infections, cardiac arrhythmias, and so on and so forth. So it's quite a long list, and I'm sure most of you have probably not really heard about these things before. And the reason is that most astronauts who have such problems never tell it to the public, and it's a private thing that cannot be shared with the community by the doctors. It's secret, and so usually these information are never shared, but this is how it is, and that's what has been published. Let me talk about 2 or 3 things a little bit more in detail before heading on. So there's space and entry motion sickness. That might be a really big issue for space tourists who go up there just for a few hours or for a couple of days, because the symptoms can be really severe. It's nausea. It's comparable to seasickness. They throw up a lot. They have epigastric complaints, headaches, and so on and so forth. And most of them have relatively mild symptoms, but symptoms are severe in about 10% of cases. And there's an irritation of the inner ear, and so the inner ear gives different information than the optical system, and the visuals and the brain is confused about those those differing information, and that causes nausea in the brain. And the symptoms usually disappear after 4 to 10 days, roughly. Can be a bit longer, can be a bit shorter, depends on the individual. And there are medications that can be taken, but they have side effects. And there are no spacewalks, EVAs, allowed during the first days in weightlessness, as it would be deadly to throw up in a spacesuit. And that's obviously why space tourists won't be doing spacewalks when they're only up there for a day or a couple of days. But this is definitely one of the space medicine issues that is most pressing for space tourists in the near future. Then another issue that I'd like to briefly touch here is decompression sickness, DCS. It's also called Casson's disease or diver's disease or the bends. You might have heard about it under those names. It's most prevalent during spacewalks, but it's also possible when there's a leak in the space station hull, for example, or in the spacecraft, and there's a sudden loss of pressure that causes air bubbles to form in the body, usually nitrogen bubbles. And those bubbles, they collect in the tissues, for example, in the muscle tissue or in the joints. As you can see in the figure here, that's an air bubble forming in a finger joint. And you can imagine that that is quite painful when the tissues are spread out that way. And the more severe thing, however, is when those air bubbles block blood vessels, and that can lead to stroke syndromes and to loss of consciousness. And those joint and muscle pains are called bends. Bends are typical signs of decompression sickness. And this sort of knowledge is important for space tourists just as much as for everyone else who's in the business, because it's important to discover those symptoms and then react appropriately and find the leak if there's a leak in the space station, for example. And you can prevent these symptoms by pre-breathing pure oxygen or by staying in the airlock with 100% oxygen, for example, the night before a spacewalk. And the mechanism is that the nitrogen will leave the body, and that way it's just possible to not get the problems. Another thing is G-measles. They happen when you get exposed to high G forces. For example, when you land too rough with your spacecraft, there's small bleedings in the skin, but also inside the body, also in the organs. They're always in the same spots, depends on the blood vessel structures. And that's why smooth landings are super important. And now briefly on the flight to Mars and beyond, missions longer than 2 years will have special criteria to fulfill. For example, immediate return is not possible, so extensive medical capabilities are required. So you basically need to be able to treat everything on the spot in the spacecraft. There will be no help coming. And the goal is to return the astronauts safely, but it's unrealistic to deliver them back 100% fit just because of payload restrictions. It's currently not possible to think of so much payload that you would need to prevent everything from happening. And then there's the danger of radiation exposure, so there need to be storm shelters in the spacecraft, and it's super important to have psychosocial countermeasures. Just 2 more slides on research. So my research deals with the musculoskeletal system in spaceflight. I deal with bones, muscles, neuromuscular interaction, intervertebral discs, etc. And we mainly work in bed rest studies. So I have a team of people. I work with international scientists from Europe, from different countries. We usually put in proposals to ESA or NASA. And then we're allowed to play in their studies and have experiments in their studies. And I'm also a co-I of the ISS experiment muscle stimulation, where we try to stimulate muscles with electrostimulation. And this is my group of international collaborators. So we've been working together for the past 10 years or so, a bit more than that. And it's very successful when you have a very diverse international group if you want to do these sorts of studies. And that's why I'm telling you about it, in case Finnish scientists want to get involved in bed rest studies or ISS medical research. It's a good idea to have international collaborators spread out internationally and to submit proposals to the space agencies together. And that also enables for funding, but that's what the space agencies want. They want international collaboration. And here you can see a picture of a participant lying in 6 degrees head down tilt bed rest, because that's how these bed rest studies are conducted. And here's one short slide on bed rest studies. So they're there to simulate a space flight with 6 degrees head down tilt because of the fluid shift. 6 degrees head down tilt simulate the fluid shift the very best. Usually they're 5, 21 or 60 days long. And solicited, for example, by ESA or NASA, and you can put in proposals. Participants stay in bed constantly. Only one shoulder is allowed to, one shoulder has to touch the bed at any time. And it's a totally controlled environment. Fluid and food intake will be entirely controlled, so you have to eat it all up. And this is an example schedule. And then here you can see a human centrifuge, which is one of the things we've recently tested in such a bed rest study. Actually, 2 years ago, we did a bed rest study to test that. And yeah, that's my talk. That was it. Thanks a lot for your attention. If you want to know more about it, you can either drop me an email or visit my website, or you can read the book that I've written together with my brother Urs, who's a Helsinki-based astrophysicist. And we've written a general spaceflight book that also touches all the medical issues. Thank you very much for your attention. If anyone has questions, I'll still be around for a while.
So thank you, Birgitta. Thank you very much. And if we have any kind of questions about this presentation, then speak up. We have still, let's say, 5 to 10 minutes, which we can spend on this topic here.
Thanks a lot for the talk. This explains why you seem familiar. Your relative with those.
That's cute. Thank you.
Yeah, it's really important topic, because now, as Birgitta said, there is commercial flights beginning. We are dreaming about going to Mars. European Space Agency is recruiting new astronauts. We're going to have a short session soon after 3 o'clock today on Main Track also about this topic. So a lot of things happening. So Birgitta, what is your take on going to Mars? Do you think this is medically possible or not?
Well, I think it's possible, but it's not easy. And there's a high risk for things to happen that cannot be solved. For example, from a medical perspective, you need to take a lot of medications and tools to be able to treat everything that may occur. So, and you can't do that. So there is a risk there that something severe will happen. But people have always been willing to take these risks also when they explore Antarctica, for example, at the South Pole or the North Pole. So it's human nature to go anyway, I think. But I think we need to make sure we prepare as good as possible and to decide as wise as possible. For example, try to choose medications and tools that are applicable for a lot of situations and that can be used in a lot of different ways. That would be clever, for example. Yeah, and I think it is possible to go there if you pick the right people and train them in the right way. And I'm very excited when the first people will go. I will certainly watch that closely and see how it goes. But it's definitely not easy.
Okay, and what is your take about moon travel? So should be the first woman walking on the moon in less than 3 years. What do you think about that?
Yeah, I mean, the Americans have been there before. Why not? They've lost the technology somehow, but currently they're making good steps forward. And I think it's quite realistic. I don't know if it's really going to happen in 3 years. Maybe it's in 5 years or in 7 years or something like that. But I think we're going to see that.
Okay, any other questions? Anybody about an astronaut training?
I might ask a question.
Yes, please.
About the effects of low gravity. So he already mentioned Mars. Is there any knowledge of to what extent are the same issues that are in zero gravity present in let's say 1/3 gravity? So human body, our bone structure requires the exercise from gravitational environment, which isn't present in ISS space station, but it would be present in Mars. Is there any kind of like knowledge or even guesses? Is that Mars experience closer to Earth or to ISS?
Yeah, so Mars will definitely be closer to Earth.
I would have thought so.
It's a little bit always the question of the dose. When you're on Earth and you're lying in bed all day, or you're sitting in front of your computer all day, you also will have experience immobilization effects, despite the gravity. So it depends on what they do and how they exercise there. But there are currently a lot of parabolic flights testing Moon and Mars gravity. You know, parabolic flights are flights in an airplane that fly parabolas to usually have zero gravity, but you can also fly them with partial gravity. And Novusbus, for example, a company of the European Space Agency, is running those flights, and you can put in experiment ideas as a researcher and then see what happens in Martian gravity, for example.
Though the health effects would not be present in what, 90
yeah,
seconds?
The health effects are definitely also there. You need to do extra exercise to be 100% like on Earth, but the question is always, how bad is it really not to be as fit? And I think it's not so bad to be not super fit in space flight. So it's unrealistic to stay 100% super athletic while on space flight. It's not really necessary, I think. But I think the locomotion will be different. Like we've seen it on the moon, people hopped and made very high jumps. And I think it will be a little bit similar on Mars. And that will be really exciting to look at.
All right, very, very interesting. So what do you think about having an astronaut? So what is your take? Should a small country like Finland have an astronaut?
I don't really. So my brother has applied, and I hope he will be an astronaut. And as he's in Finland now, and he's a Finn, I think he should become an astronaut. The astronaut for Finland, I think. That would be great. Yeah, I mean...
Urs is actually in our Center of Excellence and making a very good job. So I would welcome very warmly that Urs will be an astronaut, or Finnish astronaut as well.
I'm crossing fingers for him. But it would be nice for Finland, but I think Finland also has a lot of strength outside or without having their own astronaut. And I think you're doing really well without it too. So it's not a necessity.
Okay, thank you very much. So Birgitta, can I ask you unshare the slides so I can share my slides and we could hop further in our show as well. So now we have a small pause as we didn't have, let's see, I have also some kind of technical trouble. It seems like if I am giving up my rights as a host, then something happened also with my system. I gain a control, which is nice. So next up is coming 3 sessions again: Earth observations for society, CubeSat missions, and GNSS. And if we take a deeper look to these sessions, we have in Earth observation for society session, we have black carbon emissions measured by satellites. We have satellite-based estimates for nitrogen oxide. We have tropom emission results, and also rapid revisit deforestation monitoring with Expand-SAR from ICEYE. So we have mixed together atmospheric remote sensing and at the same time carbon sources remote sensing on the ground, and also harvester season a down-tax service supporting Finnish forestry sector presentation. Both are about the carbon stock on the ground, and then other presentations are dealing with atmospheric effects. And hopefully with this kind of sessions we are getting closer to understanding the whole global carbon cycle and system, or at least how to monitor it in a better way. We carry on also with CubeSat mission presentations. We have Lappisat, which has been grown into an entire space program in Oulu and Sodankylä. We have also news about new limits, or pushing the limits of CubeSat Earth observation. This is given by ICES. Mission description and preliminary design of Forcell 2 CubeSat. I'm trying to also hop into another computer and give a presentation on one of the sessions as well. And then there is a couple of interesting simulations and ideas about the constellations: hyperspectral small satellite constellation for Earth observation purposes, and constellation of CubeSats for astronomical observation of southern sky. So constellations are definitely the essence of cheap and small satellite. So I'm really glad to see the ideas about new constellations as well. And then we have entire session on navigation and time and location. So we have GNSS security. We have effects of Arctic wetland dynamics on tower-based GNSS reflectometry measurements. So how to combine GNSS signal with the Earth observation. We have a presentation about Incubate project, which is trying to extend the navigation signal to low Earth orbit in order to get a bit stronger signal and more penetrating signal. Another presentation about resilience, and also an overview of GNSS signal quality monitoring via Finnish National Reference Network. So these are the presentations in our breakout rooms. And at the same time, at 3 o'clock, Markus is taking the lead and introducing Kari Luojus and Maija Lönnqvist once again to the main session. And they're going to have a talk about Finnish astronaut and Finnish astronaut or ESA programs related to Finnish astronaut, because there is already, I think, more than 100 applicants to European Space Agency astronaut competition or astronaut recruitment from Finland. So altogether over Europe, I think there are tens of thousands of people applied to ESA astronaut position. And now we're going to have a talk and thinking about, is it actually possible to get the Finnish astronaut, what Finland should do in order to get an astronaut, what kind of benefits we have out of an astronaut, and how and what kind of further steps are still coming on this side. So this is the session which is going to start right at 3 o'clock. So join your sessions by selecting the proper breakout rooms. Breakout rooms are already opened, and you can join your breakout rooms and your sessions now. And Markus, if you can take over and start to prepare for the session. So
can you make me a host?
Are you already online?
I am online.
Okay. Then do we have Maija Lönnqvist?
Maija
Lönnqvist.
Let's open. Just as a reminder, we're actually going to be talking Finnish, as it's Finnish astronaut call. That's the topic, unless there is a strong position that we should be talking English, but let's see.
Niin. Kyllä suomikin onnistuu, jos sitä kuulijoimista haluaa kuulla.
Niin, ajatus oli, että olisi keskusteltu suomeksi.
No niin. Onko Maija Lönnqvist paikalla?
Joo. Täällä mä olen.
No niin. Teillä ei ainakaan video näy vielä, mutta se varmaan fiksautuu. No niin, nyt näkyy. Niin teillä oli aiheena tällainen, että saisiko niin kuin suomalainen astronautti, onko sellainen asia mahdollinen? Tämmöinenkin oli.
Kyllä, eli tällainen paneeli, keskustelu kautta haastattelu. Ja odotellaanko vähän aikaa, aloittaako 3:05 yli, vai minkälainen aikataulu meillä on tämän paneelin suhteen?
Meiltä ei ole mitään aikataulupaineita, että ihan teidän mukaan. Itse voin käydä tietysti kahvia tuosta nopeasti hakemassa, menee siitä 3 minuuttia, mutta miten vaan.
Mitäs Maijalla?
Ei mitään. Ihan aikataulun mukaan täällä mä oon paikalla.
No niin. Aloitetaan tästä vaan suoraan sitten. Niin. Mitäs teillä, mikä tämä on tämä niin kuin nykyinen status asiassa, että niin kuin suomalaisen astronautin, niin kuin, tai ylipäänsä, että suomalaisia niin kuin avaruuteen lähtisi, mikä tämä, niin kuin, onko tiedossa minkälainen niin kuin projekti se olisi? Se on varmaan tämä ESAn nykyinen haku, joka on menossa.
Joo, haluatko, että mä haastattelen, kyselen?
Te voitte vaikka haastella.
Joo, okei, no ottaako sillä, mä vaikka lyhyesti esittelen itseni ja Maija voi esitellä itsensä ja siis tämä on Kari Luojus Ilmatieteen laitokselta, osa tätä kaukartuskerhon johtokuntaa, minkä takia mä oon ollut järjestelmässä sitten tätä Finnish Satellite Workshopia. Tuli meillä sitten keskustelu, että tämä astronauttihaku, mikä nyt oli auki tässä Euroopan avaruudessa astronauttihaku, että siitä olisi ehkä mielenkiintoista keskustella. Ja mä lähestyin sitten Maijaa ja Maija Lönnqvistia ja Kimmo Kantoa, jotka siis vastaa tavallaan Suomen avaruushallinnon puolelta, sitten Business Finlandin puolelta vastaavat Suomen osallistumista Euroopan avaruusjärjestön toimintaan, niin vähän, että avaisivat sitten tilannetta, että missä mennään tämän astronauttihan suhteen ja mikä siinä on tilanne ja mitkä on odotettavissa seuraavat askeleet. Mutta ihan tällaisella oma tausta on avaruustekniikan laboratoriosta aikanaan siellä opiskellut, sinne väitellyt ja olen nykyisin Ilmatieteen laitoksella sitten töissä. Mutta Maija, haluatko ihan lyhyesti kertoa niille kuulijoille, jotka ei aikaisemmin tänään ollut olemassa plenaria, niin vähän taustaa?
Joo, kiitos. Ja Maija Lönnqvist tosiaan työ- ja elinkeinoministeriöstä. Vedän siellä meidän avaruustiimiä, joka Suomen Space Officena toimii. Olen avaruusasian neuvottelukunnan pääsihteeri ja sitten ESA-asioihin liityn sillä tavalla, että on ESAn neuvoston suomalaisdelegaatti. Kimmo tosiaan päädelegaatti ja mä oon sitten se toinen delegaatti neuvostossa. Ja astronauttikampanjahan ESAlla alkoi nyt maaliskuun lopussa ja herätti Suomessakin ihan valtavasti mediakiinnostusta. Ja siitä tietysti mielelläni kerron sitten lisää, miten se etenee tässä ja mitä muuta asialle kuuluu.
Okei, kiitos. Ihan ensimmäiseksi, niin onko tämä haku jo ehtinyt mennä kiinni nyt kuulijoille, jotka ei ole ehtinyt hakea? Niin...
Joo, jos nyt alat harkita astronauttihakua, niin sitten joudut hetken odottaa. Eli juhannuksen alla 18.6. on mennyt kiinni astronauttihaku. Ja sinne tosiaan 22 000 eurooppalaista hakemusta tuli. Tai itse asiassa niistä 300 oli Euroopan ulkopuolelta. Ja suomalaisia hakemuksia taisi olla 300 muistaakseni.
Okei, tämä edellinen hakemus Rumba Euroopan avaruusjärjestön astronautiksi taisi olla noin 10 vuotta sitten, muistanko?
Joo, 2008.
Joo, okei. No, eli tässä saattaa lyhyt odotus nyt sitten olla niille, jotka eivät osallistuneet tähän hakuun. Tietysti voidaan myöhemmin sitten keskustella vielä, että näetkö mahdollisesti, että olisiko yksityisellä puolella sitten mahdollisuuksia, mutta vielä sellainen chattiin voi laittaa kysymyksiä. Mä koitan, kun mä oon tässä vähän kyselyä, ollaan keskusteltu alkuun, niin otetaan sitten yleisökysymyksiä sieltä chatin kautta. Mutta jos mennään tähän ESAn astronauttihakuun, niin onko sulla tietoa näistä eri vaiheista, että missä vaiheessa alkaa down selection, eli siellä putoaa osa niistä, että menee tietty osa jatkoon, ja missä vaiheessa tiedetään lopulliset uudet astronauttikokelat?
Uudet astronautithan tiedetään loka-marraskuussa 2022. Eli tämähän on tosi pitkä prosessi. Ja semmoinen 6 kierrosta niitä käydään, eli nyt on tämä ensimmäinen screening. Itse asiassa en tiedä, että onko jo tullut kutsuja sitten ensimmäisen vaiheen seuraavaan vaiheeseen, eli nyt käydään hakemuksia läpi ja tietysti niitä on niin paljon. Hyvä, sieltä tuli chattiin kommentti, että ensimmäiset kutsut ovat tulleet hakijoille. Eli ensimmäiset testit on nyt sitten, ensimmäinen testikierros on nyt sitten syksyn aikana. Sitten tulee toinen testikierros, lääkärin tarkastus, pari kierrosta haastatteluja. Ja sitten tosiaan se koko vuosi menee, eli koko ajan sitten putoaa hakijoita pois. Ja osa vaan jatkaa aina seuraavaan vaiheeseen.
Okei, mä muistan itse, mä olin silloin edellisessä roadshowssa 2008 ja sitten omasta taustastakin johtuen se oli Helsingin Sanomat haastattelemassa meitä, jotka oltiin kuuntelemassa ja mä heitin silloin arvion, että sillä kierroksella todennäköisesti käy niin, että nämä Euroopan avaruusjärjestön isot maksajamaat, Ranska, Saksa, Italia varmaan saavat astronautteja ja sitten ehkä yksi paikka menee muualle, niin onko tästä minkälaista fiilistä tai ajatusta, että miten nämä on historiallisesti mennyt, että isot maksajat on ollut siellä aika hyvin pärjännyt näissä haussa? Onko siihen jotain näkemystä, Maija, sulla?
No jotakuinkin näinhän se menee, joo, että rahoitusosuus siinä vaikuttaa. Nyt on isoja maksajia, pienempiä maksajia ja sitten niitä, jotka eivät maksa mitään. Mutta nythän ESAn astronauttihaku, tai oikeastaan se astronauttijoukkio uudistuu sillä tavalla, että tulee tämmöisiä ura-astronautteja, jotka nimenomaan on näihin niin kuin pitkille lennoille tulevat ESAn palvelukseen. Ja sitten sen lisäksi tämmöisiä projektiastronautteja, jotka tulee niin kuin reserviin odottamaan mahdollista lentoa. Ja siinä sitten on paremmin mahdollisuuksia myös pienemmille maille.
Onko tästä tietoa, että montako astronauttia valitaan tästä hakukierroksesta? Käsittääkseni Euroopan avaruusjärjestelmä on tällä hetkellä 7 astronauttia, aktiivista 2 saksalaista, 2 italialaista, Ranskasta, Iso-Britanniasta ja Tanskasta. Mutta onko tietoa, montako tällä kierroksella valitaan sitten uusia näitä projekteja, sitten näitä toisia?
No niitä ei ole mun mielestä lyöty lukkoon, että riippuu tietysti, tämä on pitkä prosessi niin hakijoista ja sitten tulevista niin kuin projekteista ylipäänsä. Mulla on käsitys, että ura-astronautteja olisi about 4-6. Ja sitten taas näitä projektiastronautteja, siihen ei saa pyrkiä sitten taas niin kuin hakemaan tämmöistä hyvin kattavaa jakaumaa jäsenmaistaan.
Joo, eli
silloin kun haku aukesi, niin siinähän he niin kuin sanoi, että voi olla niin kuin paria 10-20 projektiastronauttia.
Joo, eli tällaisille, ei näille isoille maille, niin siellä on suurempi mahdollisuus sitten, että tulee tällaista pienemmästä maksaa maasta sitten esimerkiksi tällainen projektiastronautti sitten mahdollisesti jatkossa.
Joo.
Mites tilanne taitaa olla sellainen, että Suomi ei ole osallistunut näihin miehitettyjen lentojen ohjelmiin Euroopan avaruusjärjestön ohjelmien sisällä, niin onko tästä minkälainen tilanne sen suhteen on? Sitten taisit mainita, että on Temmon tehnyt selvitystä tai selvittelee sitä mahdollisuutta, niin kerrotko vähän siitä tilanteesta?
Joo, Suomi ei ole tosiaan osallistunut. Tähän on vapaaehtoinen ohjelma, eli siihen sitten jäsenmaat itse päättää, haluavatko osallistua miehitettyjen avaruuslentojen ohjelmiin. Tähän asti Suomi ei ole osallistunut, ja nyt osana nyt sitten, kun valmistaudutaan seuraavaan ohjelmakauteen, josta päätökset tehdään ensi vuoden syksyn loppupuolella, niin sitten selvitetään myös tätä miehitettyjen avaruuslentojen ohjelmaa ja osallistumisen edellytyksiä. Eli on TEMistä tilattu selvitys, jota KPMG ja Forefront tässä nyt syksyn aikana tekevät, tai ovat siis kesän aikana tehneet jo. Ja syksyllä saadaan sitten siitä tuloksia ja sitten käytetään niitä apuna sitten, kun pohditaan näitä ohjelmavalintoja sitten, kun ovat ajankohtaisia.
Joo, onko siitä vielä, onko mitään arviota, että mikä siitä suuruusluokaltaan, eli Suomen toi Euroopan avaruusjärjestön budjetti on noin 27,5 miljoonaa vuosittain, eli se on noin 0,6% ESA-budjetista, että jos Suomi liittyisi mietittyyn ohjelmiin, niin minkälaisesta hintalapusta puhutaan suuruusluokaltaan? Onko siitä vielä tietoa?
No sehän on siis vapaaehtoinen ohjelma, eli sitten jäsenvaltio itse valitsee, minkä verran siihen panostaa. Että periaatteessahan se ESAn lähtökohta on, että tämmöisen BKT-bruttokansantuotekertoimen mukaan niin osallistuttaisiin vapaaehtoisiinkin ohjelmiin. Ei Suomen nykyiselläänkään kaikissa ohjelmissa toteudu. Nyt tässä viimeisellä ohjelmakaudella ollaan jo hyvin lähellä niissä, mihin osallistutaan niin kuin monessa. Mutta siis periaatteessa osa valtioista osallistuu miehitettyjen avaruuslentojen ohjelmaan ihan tosi pienelläkin osuudella. Että se on tavallaan sitten niin kuin ihan se harkinta maalla itsellään, että mitä näkee ohjelmasta saavansa ja mitä siitä niin kuin hakee.
Joo. Mitäs arveletko, että Suomen osallistuminen tähän ohjelmaan olisi edellytys sille, että Suomesta valittaisiin astronautti vai onko tällainen näkemys perusteltavissa?
No niin kuin mä sanoin, niin pidän epätodennäköisenä tätä ura-astronauttipolkua, koska Suomi ei ole rahoittanut sitä ohjelmaa ja siellä on siis muitakin maita, joilla ei oma astronauttia ole vaikka vuosia sitä rahoittaneet. Että se mitä ESA infos näistä projektiastronauteista, niin sehän oli, että se on niin kuin avoin kaikille jäsenmaille periaatteessa siitä rahoituksesta riippumatta, mutta sitten ne lentomahdollisuudet, että oikeasti pääsee avaruuteen, niin edellyttäisi sitten kyllä rahoitukseen osallistumista myös.
Joo, ok. Jos Suomi liittyy miehitettyihin ohjelmiin, niin onko tämä rahoitus sitten pois muista ohjelmista vai onko siihen sitten haetaanko siihen sitten mahdollisesti lisärahoitusta ministeriön suunnalta vai onko tästä mitään vielä arviota siellä teillä avaruushallinnon suunnalla?
No en tähän pysty vielä, kun se on kokonaisarvio koko Suomen osallistuminen, sitten kaikki vapaaehtoiset ohjelmat, minkä verran niihin kuhunkin sitten panostetaan, että mihin sitten halutaan rahoitusta laittaa, että nämähän on niin kuin tietysti valtion rahoja, jotka sitten taistelee monen muukin kohteen kanssa, mutta tietysti se tavoite on, että se taso pysyisi mielellään niin kuin samalla, että pystytään niin kuin samalla tavalla jatkaa kuin aikaisemminkin, mutta ei tietysti niin kuin päätökset on ensi vuonna vasta edessä.
Joo, ok. Onko siellä sitten teillä näkemys tästä Euroopan avaruusjärjestön miehitystä ohjelmasta, että onko siitä ollut sitten tarkempaa tietoa, että onko eurooppalaiset astronautit matkaamassa mahdollisesti yhdysvaltalaisten kanssa kuuhun, kun ohjelma mainittiin tuossa aikaisemmassa tavoitteet mennä kuuhun. Se arvio 2024 taitaa olla aika optimistinen ja nykyisin se taitaa ehkä olla se 2026 tai sen jälkeen, mistä puhutaan, mutta onko Euroopan avaruusjärjestön mahdollisesti myös menossa sinne vai onko tästä mitään, miten Euroopan avaruusjärjestö näkee tai onko positioitunut tähän millä tavalla?
No kyllähän kuu on tosi tärkeä tässä eksploraatio-ohjelmassa ja tietysti tämä tuleva kuun kiertoradalla oleva avaruusasema ja sitä kautta tietysti on tavoitteena saada se eka eurooppalainen myös kuun pinnalle. Onko se eurooppalainen nainen kuun pinnalle itse asiassa? Mutta se on mun mielestä tavoite taitaa olla tämän vuosikymmenen lopussa, 30-luvun alussa.
Joo.
Mutta siis joo, katsotaan miten asiat tässä etenee.
Ja nämä olisi varmaan niitä ura-astronautteja todennäköisesti, jotka sitten matkustaisivat tuosta maan kiertoradan ulkopuolelle. Mainitsit sen Q-aseman Gateway-aseman, mitä pyritään rakentamaan sitten näitä laskeutumisia ehkä vuosikymmenen loppupuolella. Ei tarvitse vielä vastata. Okei. Muuten chatti on auki kysymyksille. Mä ehkä kysyisin sitten tässä vaiheessa, että mitkä nämä Suomen avaruushallinnon keskeiset ohjelmat on Euroopan avaruusjärjestössä, tai osaatko vähän avata niitä tämänhetkisiä ohjelmia, ollaan kaukartus, tiede, navigaatio, että missä ohjelmissa ollaan mukana ja jatketaanko edelleen näissä samoissa ohjelmissa jatkossakin?
Joo, tällä hetkellähän ollaan siis kaukokartoituksen eri ohjelmissa, navigaation, tietoliikenteen ja sitten avaruusturvallisuuden ohjelmissa ja sitten tietysti tiedeohjelmahan tulee niin kuin tavallaan pakollisena osallistumisena. Ja varmastihan nämä on siis Suomen prioriteetteja ja vahvuuksia jatkossakin. Mutta tietysti jos katsoo tämän päivästä osallistuja-esityslistaa ja näin edelleen, niin kyllähän tässä niin kuin tapahtuu paljon, että miksei tästä nyt niin kuin voi laajentaakin. Että tosiaan tämä miehitettyjen avaruuslentojen ohjelma on sen takia tässä nyt niin kuin selvityksen alla, että olisiko hyödyllistä sinne osallistua.
Joo. Onko siitä päätöksiä tulossa tämän vuoden puolella, ensi vuoden puolella, miltä tilanne näyttää sen suhteen? Vai tuleeko päätökset siinä vaiheessa, kun se seuraava Suomen osallistuminen Euroopan avaruusjärjestön ohjelmaa ja se ministerin budjettikokous tapahtuu, olikohan se nyt ensi vuoden loppupuolella sitten?
Joo. No, ensi vuoden loppupuolella marraskuussa on ESA ministerikokous, jossa tosiaan sit sitoudutaan tähän seuraavan 3 vuoden rahoitukseen. Eli ennen sitä sitten päätetään Suomen niin kuin ne sitoumukset. Yhdessä alueen toki ennen sitä, mutta tavallaan sekin riippuu sitten siitä, että niin kuin tiedetään se ohjelmien sisältö ja on tehty se kansallinen valmistelutyö.
Täällä on chatissa kysymys, että minkälaisia töitä Suomen avaruushallinnolla on avaruusasioista kiinnostuneille?
Hauska kysymys. No jos mä ajattelen Suomen avaruushallintoa laajasti, että tässä on erilaisia virastoja ja ministeriöitä, niin sittenhän meillä on täällä ihan teknisiä asiantuntijoita ja juristeja, hallinnon asiantuntijoita ja varmaan niin kuin rahoituksen asiantuntijoitakin. Aika paljonhan, jos ajatellaan taas niin kuin ihan meidän tiimiä, niin meitä on 4, eli ihan hirveän montaa työpaikkaa ei meille sitten mahdu, että meillä on niin kuin sekä pääasiassa juristeja tällä hetkellä myös yksi tekninen henkilö. Ja sitten tietysti on näitä muita virastoja ja ministeriöitä, joista työpaikkoja löytyy myös. Mutta periaatteessa siis tarvitaan juridista osaamista, teknistä osaamista erityisesti, ymmärrystä kansainvälisestä yhteistyöstä ja niin kuin tavallaan ehkä sitä valmiutta ajaa suomalaisen sektorin etua ja intressiä kansainvälisissä piireissä. Eli niin kuin näitä delegaattitehtäviähän on hyvin paljon ja pääosa meidän asiantuntijoistahan hoitaa niitä tavallaan osana muuta työkenttäänsä.
Joo. Ok, kysymys sitten vielä. Eli mitä muita, tai sivusit näitä silloin aamun plenarissa, mutta mitä muita ohjelmia kuin Euroopan avaruus, tai mitä muita organisaatioita on sitten niin avaruushallinnon alla tämän Euroopan avaruusjärjestön lisäksi? EUlla taitaa olla kohtalaisen isolla budjetilla toimiva tai toimivia ohjelmia, niin onko niistä jotain, näetkö mahdollisesti, että Euroopan avaruusjärjestön rinnalle tulisi Eurooppaan toinen iso toimija Copernicuksen tai EUn alle?
No EUhan on jo iso toimija avaruuspolitiikassa, eli EUlla on tämä oma avaruusohjelmansa, tosiaan mihin kuuluu Copernicus, Galileo ja EGNOS, tilannekuva ja COMSATCOM. Ja sehän on siis niin kuin tämmöinen operatiivinen ohjelma, että jos ESA on enemmän sitten taas siellä TKI-puolella. Eli ne täydentävät toisiaan. Ja tietenkin kyse on niin kuin julkisista organisaatioista, niin joilla on pääosin samat jäsenmaatkin vielä, niin olennaistahan siinä on, että ne tekee niin kuin eri asioita, toimivat niin kuin rinnakkain yhteistyössä, että ei ole niin kuin päällekkäistä toimintaa. Mutta tosiaan tämä EUn avaruusohjelman 7 vuoden budjettihan on vajaa 15 miljardia, että sekin alkaa olla hyvin iso ohjelma. Ja nyt kun avaruusohjelma alkoi keväällä, niin aloitti toimintansa myös siis EUn avaruusohjelmavirasto, joka sitten hallinnoi tätä EUn avaruusohjelmaa. Ja tosiaan toimii sitten taas niin kuin koko tämä EUn avaruusohjelma toimii hyvin läheisessä yhteistyössä ESAn kanssa. Eli ESA on itsenäinen kansainvälinen järjestö, ei ole EUn osa, mutta yhteistyö on kuitenkin läheistä ja tiivistä.
Okei, joo, mutta muutama iso toimija ja EUn avaruusvirasto, mikä on, tai Euroopan unionin avaruusvirasto, mikä on aika tuore, niin se on kasvanut erittäin voimakkaasti viimeisen 15 vuoden aikana. Mutta jos palataan vielä miehitettyihin lentoihin, niin miten näet sitten jos mietitään suomalaiselle astronautille mahdollisuuksia ja jos mietitään, että mahdollisuudet vaikka sellaiseen ura-astronauttiin on aika pienehkö, tällaiset projektiastronautiksi mahdollisesti sitten huomattavasti isommat, mutta mitä sitten kokonaan eri puolelta, että yksityiseltä puolelta? Eli nyt näyttää siltä, että näitä yksityisiä astronautteja ja avaruuslentoja on tullut enenevässä määrin, eli on sekä kiertoradalle että sitten tällaisia NS 100 kilometrin avaruushyppyjä, niin jos sun pitäisi arvata, niin onko meillä ensimmäinen suomalainen avaruudessa kaupallisen toimijan kautta vai Euroopan avaruusjärjestön kautta mahdollisesti?
No siis periaatteessa kai näille yksityisille toimijoille voi ostaa suoraan lipun, että siinä ei tarvitse treenata astronautiksi, mikä on kuitenkin useana vuoden hanke, että jos vaan avaruuteen pääsee, niin veikkaisin, että ensimmäinen suomalainen menee kaupallisen toimijan kautta 10 minuutiksi avaruuden rajan toiselle puolelle.
Joo, siltä vaikuttaa omasta mielestäni myös, ja yksityisen kauttahan sitten näyttäisi, että myös nämä periaatteessa nämä NASAn ja Euroopan avaruusjärjestön astronautitkin on jatkossa matkustamassa, eli SpaceXn raketeillaan heidän aluksillaan.
Joo.
Mutta mulla oli kysymys, Patteri, tässä chatista nyt ei ole kovin paljon uutta tullut. Olisitko sä halunnut vielä puhua jotain, minkä aikaa Suomessa on ollut avaruushallinto? Vähän avaat, Suomen NASAa ei nyt ole hirveästi mainostettu, niin vähän, että minkälainen historia Suomen avaruushallinnolla on ja avaat vähän tätä, että mihin suuntaan se on menossa seuraavien vuosien aikana.
No onhan Suomella tietysti avaruushallintoa ollut niin kauan, kun on oltu erilaisissa avaruusasioissa mukana, että ehkä niin kuin avaruushallinnon voidaan katsoa sit syntyneen 80-luvun lopusta, kun avaruusasian neuvottelukunta perustettiin 89, ja sehän nyt edelleen jatkaa toimintaansa. Ja mun mielestä säännöllisin väliajoinhan käydään keskustelua siitä, että pitäisikö olla avaruusvirasto. Ja haaveillaan, että sellainen ehdottomasti pitäisi olla. No, tähän asti on nyt menty tällä hajautetulla mallilla, että nyt sitten tämän viimeiset pari vuottahan on sitten pyritty tiivistämään tätä koordinaatiota, vaikka meidänkin tiimin ja avaruusasian neuvottelukunnan sihteeristön ja neuvottelukunnan niin kuin uudelleen organisoitumisen kautta. Eli hyödynnettäisiin se, että kun on pieni maa, niin on ehkä hyvä, että on tämmöinen hajautunut hallinto, jolloin saadaan niin kuin mahdollisimman laajasti sitä asiantuntemusta käyttöön ja sitten taas toisaalta pystytään reagoimaan nopeasti alan muutoksiin ja tarpeisiin. Mutta tietysti se vaatii sitten taas niin kuin koordinaatioita ja tiedonvaihtoa niin kuin entistä enemmän, varsinkin kun näitä velvoitteita tulee lisää ja lisää. Kansainvälinen toiminta ja eurooppalainen avaruustoimintakin niin kuin kasvaa ja kehittyy. Että ehkä viimeiset muutama vuosi on ollut on niin kuin just tähän koordinaatioon panostettu entistä enemmän, varsinkin kun ehkä näitä toimijoitakin on niin kuin koko ajan enemmän. Mutta avaruushallinto sinänsä ja näitä toimijoitahan on ollut olemassa vuosikymmeniä.
Joo, ehkä tämä mun sanamuoto oli väärä, että avaruusvirasto oli ehkä se, mitä hain, että onko sellainen jossain vaiheessa horisontissa, että perustetaanko sellainen Suomeen? Tai
niin,
siihen.
Sitä ei tiedä, joo. Sehän voi olla, että tulee tarpeelliseksi. Tai sitten ei, jatketaan samaan malliin, että seurataan, miten sektori kehittyy ja miten hallinnon on tarvitse kehittyä myös.
Okei. Minulla olisi nyt vielä kysymys, eli meillä oli tuossa chatissa yksi ihminen, joka oli osallistunut siihen hakuun, niin olisiko meidän mahdollisuus saada häneltä, Daniel Rotkolta, kommentteja siitä hakemusprosessista tähän asti? Onnistuuko sieltä Markukselta yhden osallistujan lisääminen tähän paneeliin?
Joo. Katsotaan, mikä oli nimi?
Daniel Rotko.
Onko Janielilla ääni päällä tällä hetkellä? Daniel Rotko, no niin siinä.
Onko Daniel?
Kyllä.
Jos onnistuu ääniyhteys, videoyhteydenkin saa luonnollisesti ottaa, niin kysytään vähän astronauttikandidaatilta tästä hakuprosessista.
Joo.
Nyt pitäisi olla päällä, kuuluuko?
Joo,
Kuuluu.
nyt kuuluu.
Yes.
No niin, haluatko kertoa muutamalla sanalla omasta hakuprosessista tähän asti ja siitä, että miltä tämä hakuprosessi näyttää jatkon kannalta?
Joo, no siis minä olen osa isompaa suomalaisten ryhmää, jotka on hakenut vähän niin kuin poppoossa tuohon astronauttihakuun, eli siellä on niin kuin isompi koko populaatio. Että jos olette yhtään Ylen ja muiden noiden uutisverkkojen uutisia seurannut, siellä on ollut haastatteluja erinäköisiltä noita hakijoilta, niin ne on käynyt ottaa kaikki tuosta ryhmästä, missä me ollaan. Meitä on semmoinen 25 henkeä siinä. Itse hain sinne, minä olen tehnyt siis tästä hakuprosessista jo 2 vuotta. Et 2019 minä sain jo tietää tästä ja siitä asti minä olen vähän kerännyt kasaa poppoota ja olen ollut muun muassa tuonne TEMin puolelle itsekin yhteydessä tästä aiheesta. Ja nyt tosissaan se haku sitten aukesi tuossa puolisen vuotta sitten. No ei se ihan puolta vuotta ole mennyt, mutta melkein. Ja ensin oli paperihaku. Piti pistää vähän terveystodistusta ja ihan tämmöinen yleinen paperihaku. Ja sitten sen jälkeen nyt tuossa puolitoista sitten, niin haku meni kiinni. Ja nyt on sitten noita ensimmäisiä kutsuja pistetty ihmisille. Itselle on tullut kutsu, minun käsityksen mukaan, niin ensimmäistä joukossa Suomessa. En ole kuullut kenestäkään muusta, en ole myöskään kuullut, että siellä olisi niinku yhtään suomalaisia tullut, että siellä on tuommoisia Euroopan laajuisia porukoita, jotka pitää kirjaa näistä, ketä on hakenut ja millä profiileilla sun muuta, niin ei ole vielä minun käsityksen mukaan näistä muista 300 suomalaisista tullut hakijoita, mutta se ei niin kuin siinä mielessä tarkoita, etteikö lisää väkeä kutsuttaisiin sinne, koska tämä niin kuin tulee jatkuu vielä useamman kuukauden tämä hakuprosessi, sinne haki niin paljon ihmisiä. Niin nyt vaan otetaan peukut pystyssä, että en jää ainoaksi, koska en minä kyllä usko, että me tästä hirveän pitkälle sitten seuraavassa vaiheessa tuu selviin.
Joo.
Ei, et usko omiin mahdollisuuksiin älyttömän korkealle.
Pessimisti ei pety.
No niinpä tietysti. Näin se menee.
Joo.
Okei, joo, kiitos tästä informaatiopalasesta. Nyt on mahdollisuus kysyä suorassa lähetyksessä vielä Maijalta jotain. Jos jollain on kysymyksiä, niin chatti on auki. Ja jos ei, niin mä sitten ojennan tämän puheen takaisin sitten sinne studioon Markukselle. Olisiko Danielilla ollut vielä tähän väliin jotain?
Ei oikeastaan muuta kuin, että tiedän, että tässä on muutama muu hakija myös kuuntelee täällä näin. Muutama pisti minulle viestiäkin ihan tässä hissukseen. Niin
okei, itse asiassa
ei mitään, nyt vaan oottelette.
Joo, mä kysyisin, että onko ketään, kuka haki 2008 haki nyt uudestaan? Et mä tiedän, että muutamia mun tuttui 2008 pääsi kohtuu pitkälle jatkossakin, että olisiko ketään sellaista nyt linjoilla. Ehkä ei.
Ehkäpä ei.
Okei, sitten mä kiitän Maijaa tästä paneelista, haastattelusta ja sitten palautan takaisin sinne studioon Markukselle.
Joo. Eli joo, kiitoksia haastattelusta ja meillä ohjelma täällä jatkuu tuosta vähän ajan päästä. Siellä tulee eri Zoom-huoneissa on jälleen muutama ohjelma tästä vielä meidän ohjelmakartan mukaan. Kiitoksia vaan teillekin.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology is the first truly global ability to look at things on daily and sometimes sub-daily basis. we can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions. We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide.
Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään semmoista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin oli Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatio, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyy käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
So, hello everybody. I think the session room started to be closing again. Is there already somebody online? Can you hear me? So we should start to prepare for the evening interactive sessions. So, how was the sessions? Tuukka, can you tell what happened in GNSS session?
I was only a participant there, but yeah, there were some discussions still going on, but maybe Sahid can continue if you have something to add.
Excellent. But anyhow, so from technical point of view, the session happened, everything was all right.
Yeah, at least everything worked. So.
Excellent. Mikko, how was the Earth observation session? I presume you attended the Earth observation session.
I did. I think the only technical hiccup was me dropping out when my computer shortly bumped, but I got back with my mobile phone, so I don't think that the participant noticed it too much.
Yeah, it's the best we can do during this COVID time. So technical problems occur from time to time. We lose some time, but at the same time we are gaining some time, not traveling too much. So so far so good. So I'm also confident that the CubeSat session happened. Is there anybody to tell what was happening in the CubeSat session?
Well, a new space program was presented. That was really nice. LAPI space program.
Excellent. Yes, I was actually listening there as well, and I think in 7 minutes we should start to have our poster sessions as well. So we have poster sessions in 2 separate parts. We have first 20 minutes, first 10 presentations are here. One of those was cancelled, so this number 5 room is empty. And then we have the second slot of presentations starting 20 minutes later, 16:50 till 17:10, and here are the presentations which are presented there. When we go to these rooms, I'm leaving the slides open here in order you can select the room, because the names of the papers are just too long to put them on as a room name. So you have to just choose the number or hop from room to room to discuss with these people. Somebody also asked how to upload your material, which will be linked to the program, and I'm trying to show this to you now as well. So you had this abstract submission system, and in the abstract submission system you also got an email which sent you a code with what you can open your abstract submission anytime again. So this is my abstract submission system, and here you can see now we have also areas like file upload, which is a Google file upload, and it will upload your files into the Google Drive of the conference. And then there is an alternative file upload, which is just a text field where you can copy and paste a link. So if you don't want to put your material to Google Drive and you want to just share the link, then you just share the link here, or then you upload your material here. We have been setting the limit for your material is 10 megabytes per material, and it can be anything. It can be a presentation, a picture, a PDF, a short video, or something like this. And I need to do a bit of work in order to get this also linked but I'm confident that by tomorrow morning, today's material, which is uploaded, will be already linked to the schedule, and it will be also linked to the homepage of the conference. So everybody who have access to the homepage of the conference will have access also to your additional files. Any questions about that?
What will happen with the video, Jan? You mentioned video.
I mean, if you have a video which you upload yourself, then a short video can be attached as a short material, but we are recording all the presentations, and we also will ask separately your permission to put these videos online, presentation by presentation, but will take another month to get this online, but we try to give access to the world, to our studies as much as possible.
Okay, thanks. Then Jan, I'll just quickly ask for tomorrow, should I change the CISPO talk to OPIC now?
I can do this, yes, we'll do it.
But I can use the the link that you sent and edit myself.
Okay, that's good.
Okay, I'll do that.
So
thanks.
actually, you just need to replace your abstract number in the schedule, and then everything will be up to date.
Yeah, but I don't have the OPIC talk, so I have to kind of change something. Yeah.
Okay, then just do it. All right. Any?
Jan, it just worked for me now to do the upload via this original page. So
Excellent.
it works now.
Okay, excellent. So I will add additional column to the schedule, so everybody will access the links as well. But yes, so we are getting very close to interactive session, which starts 4:30. It has been already a very long day. I'm really glad that you have been bearing with me. And so during the last hour, we have our interactive sessions, and you can either take a look on the schedule or take a look on the screen and see what kind of sessions we're going to have. Let's see, we have already rooms created, and I'm really encouraging everybody to check now the rooms and check now also the schedule, what kind of abstract or what kind of room you would like to join. There is also my own presentation about Aalto-1 satellite, which has been 4 years in space. Juho, are you already online? Excellent. I see Juho here. So Juho, can you join room number 6? Then we can talk with people who are interested in Aalto-1 satellite, which has been the longest living Finnish satellite so far. So, welcome back to the online, and now we can also go to the second part of our interactive sessions. I hope you had fascinating time with your sessions with different people who are online. So take now time to make you familiar with the second set of interactive sessions.
Jan, are you there?
Yes, I am.
Which one is Maija Lönnqvist's regulation session?
What we have been having a problem. Now I see we have a problem. Maija. Let's create one right away. Let's assign so Suvi, can you create another room, 12 or something? Because it seems like how this has been, or was it actually? Let me refresh the. I think it has to be room number 12, but let's go to room number testing for Maija's presentation, and So what we have to do, Maija and others, so I propose that we create a special room after this session. I'm really sorry, it seems like something has been not updating as it should have been. So we were not creating the room in time. But Maija, you can give your presentation 17:10, so in 10 minutes or 14 minutes you can give your presentation in the main room to all the audience. So I will hold everybody back for 15 minutes to have a small presentation about CubeSat licensing and satellite licensing in Finland. Would it help?
Jan, is number 8 still existing, and did you change the topic of that or something?
No, I didn't.
It seems Emil Winterhalf is missing.
Okay, then this is just like the presenter is not here at the moment, and this is all I can tell. You can also contact with Emil during industry hours, I hope. The presentation is actually about this PASQ company who is actually making the testing services of IRF in Kiruna.
Okay. And do we have is there basically for the regulatory stuff session still?
This is tomorrow.
That's tomorrow. Okay, so that's confirmed.
So we have tomorrow morning from 10:45 till 11:30, we have a session called QAPA. And we have a couple of very interesting presentations there. Paavo Heiskanen is giving the first presentation about mission assurance in new space. Marko Pudas is going to tell about conformal coating with ALD for thin whiskers. And then we have a faster platform to decrease the cost of testing of space technology in parabolic flights. And Miguel Angel Ruiz Sosa is going to give a presentation about X-ray technologies, which Yxlon is going to or is able to deliver at the moment.
Yeah, looking. Okay, thanks.
Hi, Jan.
Hello.
So I updated the abstract.
Excellent. I
So
will
it's
take.
completely new title and everything. I don't know how it works. How do you accept it? But it should be there.
Okay, it will be in tomorrow's schedule with all the updated abstract and everything. I will take
Okay.
care of that.
Yeah, great. Thanks.
All right. So we are starting to close to be close to the conclusion of the day, and we have had extremely long conference day and rather intensive, but we didn't want to make this day any longer than 9 hours continuous program. So if you have any reflections or any technical tips how to make this one somehow more interesting, more smooth, just speak up, give us some tips for tomorrow, and we will have a very similar dense program for entire day tomorrow. So Kannan, how has been the GNSS session, and did you find anything interesting from the conference? Kannan, you are muted. Right, it seems like we lost Kannan. Anybody else? Markus Törmä, you were also online at some point. Kannan, you are now online.
Yeah, sorry, I couldn't hear.
So, how has been your day at Finnish Satellite Workshop and Remote Sensing Day?
It was really fantastic, and overall, like, there is a lot of information. I have been like attending this workshop for like last 2 years as well, and this year as well. So there is a lot of progress in the Earth observation side as well. There are new missions, satellite missions that are being worked on and being shared with such huge audience, and it was very informative. Thank you.
Excellent, that's good to hear. Any technical troubles you had? Anything you think what could be made in a better way?
So far, so good.
Yeah, it's the first online conference for our team as well, so we have been a bit trying this and that, and not necessarily everything is working. So I already have some proposals how perhaps make the industry hour a more smoother experience. Especially something like industry hour is really difficult to make smooth for online, because it needs a personal contact. So it's not so easy that you just like set up a room and you have it.
Yes, definitely, I will appreciate it. Thank you so much.
All right, Samuli, you are all online as well. Can you hear me?
Yes, I can hear you.
Excellent. So I think this is Samuli Newman. Are you? Or
Okay, no, this is not similar.
This is not the same Samuli, but Samuli, can you tell how was your day at Finnish Satellite Workshop and Remote Sensing Days?
Yeah, it has been very interesting. This is like my first attending it for the first time, and all the topics have been interesting and nice to learn on the progress of satellite technology in Finland.
Excellent. And where are you from yourself?
From the University of Vaasa.
Okay, you are from Vaasa, so
Yeah,
you are
yes.
then getting a homeland overview, which is really really good and really nice. So I see also we have a bit of international guests here, but not so many perhaps anymore. All right, do we have anything else to discuss, or should we just close the meeting for today and trying to relax and getting good night's sleep for tomorrow, because tomorrow we're going to have a very intensive day as well.
Do you know the recordings, where are they and when?
Recordings, all the stuff has been recorded, but because Zoom is recording everything to our computers, so my team is taking down the recordings of every session. Probably we will lose also 1 or 2 sessions, hopefully not. And then we have to split them up and see how we're going to link them or how we make them available. But they are existing, but it takes some time to get them online. And I already promised that tomorrow we have in the schedule also links to the additional material available. All right, any other questions, proposals, ideas, comments? If no, then I would say have a nice evening to everybody, and let's end the conference for today here. The conference channel will stay open for another, let's say, 10 minutes, 15 minutes. Suvi, can you make a couple of channels for people to chat if they would like to? I will put the logo on the main screen and our music playing on the background, so you know that the conference is existing. But see you all tomorrow.
Thanks for the effort, Jan. Really great. Thank you.
Thanks.
Thank you. See you tomorrow.
Thanks, everybody. Sauna and beer.
That's a good plan.
Thank you.
Thank you very much, North Face.